Hello everyone, welcome to the Windows Penetration Essentials course. In this video, we're going to be taking a look at setting up our penetration testing distribution and the hypervisor that we'll be using. Later on in this section, we'll get started with setting up our vulnerable boxes, and then we'll finally conclude with installing the various tools that are very helpful or that are used when performing Windows penetration testing. All right, so let's get started. Now, as you can see, my host operating system that I'm using right now is Windows 10. So again, this video and the installation instructions will work for any operating system, regardless of whether you're using Windows, Linux, macOS, even BSD, right? So we've opted to use VirtualBox and Kali Linux as our pen testing distributions, and for good reason. VirtualBox is completely open source, which means you don't have any issue of licenses, and you can essentially install it on any operating system really easily. And for Kali Linux, it is one of the most popular penetration testing distributions and one that is supported by many organizations as the official de facto standard. So let's get started. Now, I'm just going to open up Firefox here, and you can see I'm currently on the VirtualBox download page. And you can do that by going to virtualbox.org and wiki downloads, right? And this will give you the various binaries for your various operating systems. So you have Windows, macOS, Linux, Solaris, etc. For your Linux distributions, you don't have a binary. Instead, you have the actual installation instructions for the various package managers. And in the event you do have the actual binary or the source code, there are instructions on how to compile the software yourself. So that shouldn't be an issue at all. So once you've downloaded VirtualBox, you can go ahead and install it. It really is a very simple install in terms of the installation wizard on Windows. It's even simpler on Linux and macOS. All right, so once you have VirtualBox installed, we can now get to the actual meat and potatoes, which is Kali Linux here. So you want to go head over to Offensive Security, and if you go to kali.org under downloads, we are not looking for the ISO file, right? So the ISO file is essentially the installer. And we don't want to go through the Kali install. The reason for that is we're going to be working in a virtualized environment, which means we can actually use their official VMware or VirtualBox images, right? So in our case, we're using VirtualBox. You can go ahead and use VMware if you want. It's entirely up to you. So I'll click on the Offensive Security VM download page, and this will give us the various images for the various hypervisors. So for example, for VMware, we have the images here. For VirtualBox, we have the images here, and you can download the latest version. And the great thing about downloading a VM image is it already has everything installed, and you really do not need to go through the install process. You just need to click on the OVA file or the OVF file, and it'll import the virtual machine for you, already installed, and you can get started immediately. All right, so once you have that downloaded, we can now get started. In my case, I have my virtual image here that is currently the version 2019.4, so it's a bit outdated. And again, I recommend that you use the latest version. The reason I have the outdated image is because I can easily just update the packages and update the entire distribution whenever I want to, instead of downloading the new image, right? So as you can see, this is an OVF file. If I just expand this, and that means you just need to double click on it, and it's going to bring up the VirtualBox page here. Now, in my case, I have various virtual machines, but in your case, you won't have any if this is your first time using VirtualBox. And this is going to prompt you to import the virtual appliance, where you can specify the various options. You can actually take a look at the various options here, and it'll actually point out the directory to which the actual the virtual disk image will be stored, or the virtual machine disk right over here. And you want to specify wherever you want to store your virtual machine, and then click on import. In my case, I already have my Kali VM set up here, and it's already updated to version 2020.2. So that's the latest version as of recording this video. And you can pretty much use one virtual image. And again, you can then just keep on updating it and upgrading as you feel is appropriate. All right. And the other great thing about VirtualBox is the ability to take snapshots. Now, this is not exclusive to VirtualBox when generally speaking about hypervisors, but it's very important that you take a snapshot of your virtual machine. And what this does, it preserves that state in which you actually set up your VM in that pristine state. And whenever you make a mistake or there's an issue with the operating system or the virtual machine, you can easily roll back to that particular snapshot. So in my case, you can see I have a snapshot called Kali Linux 2020.2 rolling. And that is a snapshot that I can always revert to in the event something does happen in my current state, which, as you can see, is changed. So again, to take a snapshot, you can just right click here on, and you want to make sure that you click on this little menu here, and then that will allow you to view the details of the VM, which is pretty much the page you should be seeing. If you go to snapshots, you'll be able to take a snapshot of your current state. In my case, I've already done that, so I won't be doing that. As for your settings, you can pretty much assign as much system resources as you can. I would recommend about 2 GB per virtual machine. And the most important is the network settings, where you want to ensure that this is on the bridged adapter, and you want to specify your actual interface here, or your network interface card. In my case, it's a Realtek PCIe network interface. So I'll just hit OK, and we're ready to go. And then I can just click on start. That's going to start up my virtual machine. And if I just minimize that for a second and we'll go to details, the default credentials for the virtual image are actually added as a description here. So you can see the default username is root and the default password is Tor. All right, so now that we have that set up, we can actually just open up the VM here, and it's currently starting up. So I'll just get that set up immediately. And in the next set of videos, we're going to be taking a look at setting up our virtual environments, and then we'll take a look at installing some of the important tools we'll be using to perform penetration tests on Windows. All right, so we'll just give this a few seconds, and that's going to start up Kali Linux for us. In my case, I've already changed the password, so I'll just enter my root username, and I'll just enter the password to which I changed it to. So that's the first thing you want to do after a default setup of your virtual image. It's going to give you a default installation with the default credentials of root and Tor. So you want to open up your terminal here. In my case, I'll just do that right now, and I'll just open up bash here. And the first thing you want to do is hit password, and you want to hit enter, and that's going to allow you to change your Linux password here for the root user or the user that you're currently logged in as. In my case, I'll just enter a new password, and there we are. The password is updated successfully, and you have now changed the default root password. So that's going to be it for this video. In the next set of videos, we'll get started with our virtual environments, and then after that, we'll take a look at installing the various tools that we're going to be using on Kali Linux. So I'll be seeing you in the next video. Hello everyone, welcome to this video. In this video, we're going to be taking a look at setting up our own virtual hacking lab and setting up our targets and our virtual hacking lab network. All right, now in the previous video, we've already taken a look at setting up our attacker VM, which is running Kali Linux, right? And regardless of what operating system you're running as your host, it could be Windows, Mac, or Linux. Once you've set up your hypervisor, in this case, it's going to be VirtualBox, everything should be replicable on your side. Now, our target operating systems for this particular course are going to be Windows 7, and this can be any version and any service pack of Windows 7. And Metasploitable 3. Now, Metasploitable 3 is an intentionally vulnerable operating system that is set up to help users and students understand how to exploit Windows systems or Windows server systems and the various services that are running on it. Now, Metasploitable 3 is a virtual machine that is based on Windows Server 2008. All right, and if I open up my browser here and we go to the GitHub link to Metasploitable 3, which will be added as a resource to this video, you can find it under github.com rapid7 Metasploitable 3. And this page will essentially have all the build instructions to help you build it. And you have the requirements here to actually go through the build process. So you need VirtualBox, you need the Vagrant Reload plugin and Packer, and you also have the build instructions here. Now, we also have our own build instructions and a video tutorial that is available for free on YouTube that will actually cover how to set up Metasploitable 3 for yourself. Now, you might be asking yourself, why do we need to do this manually? And the reason for that is because you're dealing with a Windows operating system, and Windows has very strict licensing terms in terms of how you can distribute the operating systems and under what terms. Now, for this particular course, we're going to be providing you with the OVF file, which is the open source virtualization format file, which again is just the VM image. So you don't have to go through the build process yourself. So that will also be added as a resource to this video. And you just need to double click on that and it will set up the VM for you, as we did with the Kali Linux VM. All right. So you can go through the build instructions if you want to build it yourself based on the operating system you're using. The OVF file will work on any operating system as long as you have VirtualBox installed. All right. And our second operating system, as I said, is going to be Windows 7. Now, As of recording this particular video, Windows 7 is now discontinued, and as a result, Windows does not offer any evaluation images on their website. So before, you had your TechNet Evaluation Center where you could download various Windows 7 virtual machines, and you could use them for a period of 90 days until they were deactivated. Now, for the purpose of this video, you can find your various Windows ISOs under windowsiso.net, and again, this is just public disclosure. Again, you can it's entirely up to you as to whether you want to use this, but these are not activated versions of Windows. So there is going to be a certain period of time where they're going to be running as not activated, which is perfectly fine. That's because these exploits do not need an activated version of Windows to actually run, or you do not need an activated version of Windows to actually use the operating system for exploitation purposes. All right. In my case, because I'm actually carrying out a demonstration here, I have licensed versions of Windows, and again, that is part of Microsoft terms. If I'm going to be using their products for demonstration purposes, I need to be activated. So I just want to make that clear as possible. All right. And you can download the ISO here. Now, I already have the VM images. So if I go to my files here and go into my VMs and ISO files, I already have my Windows 7 VirtualBox file here, which I can easily set up. I already have Windows 7 set up in VirtualBox already. So these are the OVF files. So all you need to do is just double click on them and they'll ask you to import it, and that's all. And as I said, we already have one set up for Metasploitable 3, which will be added, and you can use that for yourself. It's about 6 GB, which is a large download, but again, it is a requirement for this particular course. So again, you just double click on it and that'll give you various instructions to import the VM. So you specify the actual import directory, and you should be good to go. All right, so once we have that set up, we can now begin setting up our virtual hacking lab network. All right, so to do that, we want to open up VirtualBox here and we want to go into our preferences. Now, I already have one of my own networks set up, so I will just get rid of this. So I'll just delete that and I'll just hit remove. All right, so within the network preferences here, we want to create our own NAT network. Now, the reason we're doing this is because we want all our VMs in our hacking lab to be on the same network so that they can communicate with each other, to have the same subnet essentially, which will help them be identified much more easily. So again, we want to create one, and you want to click on this little green plus button here, and we can then edit it. So we can right click and click on edit NAT network, and we want to change the name to something that we'll recognize. So we'll just call it a virtual hacking lab, right? And for the network CIDR and subnet, we're just going to change this to 10. So we'll just get rid of this. So we'll say 10.0.0.1/24. So this is going to be our network address here again, and we have our subnet. So this is a medium-sized network, and we want to ensure that it supports DHCP. So that is going to set up the VirtualBox DHCP service, which is going to be responsible for assigning new IP addresses to new devices that we add to the network. All right, so I'm just going to hit OK. And we just want to hit, we have some invalid settings here. Looks like we have an invalid setting with the actual CIDR. Let me just check what the incorrect options are. So I'll just set that to 0 and we'll just hit OK. And that should be OK now. So ensure that that is set to 0. That's because we are starting off fresh there. All right, so I'm just going to hit OK. And the first virtual machine we want to add to the network is going to be our Kali operating system, or our VM. We want to click on that. We want to go into network, and we want to specify the NAT network. So not on the bridge network anymore. We're going to click on NAT network, and we want to make sure that it's the network name is Virtual Hacking Lab, similar to what we had set up just a few seconds ago. The next operating system is going to be Metasploitable 3. You want to go into your network settings and again ensure that it is on the Virtual Hacking Lab network here under NAT network. And again, we'll do the same for Windows 7. And in my case, I'm running Windows 7 Enterprise. We're going to go into network and ensure that it's on the NAT network and it's under Virtual Hacking Lab, and we're ready to go. So now we can essentially test this and start noting down the actual IP addresses and test whether we can communicate. We can actually connect to each other from, we can actually establish a connection between these boxes now that they're on the same network. So I'll just click on start now. And this is these network settings are only going to affect the virtual machines that are currently set up to use that network. In our case, we've only set up Kali, Windows 7, and Metasploitable 3. So we're just going to start up Kali here. and Metasploitable 3 as well. We'll also start up the Windows 7 box. And the reason I'm going to be starting up Metasploitable 3 is because there are a few settings you need to set up or that you need to know so that you can actually log in and we can test out the IP configuration here. So that is Windows 7 starting up, and we also have Metasploitable 3, which is a Windows Server 2008 box. Let's check up on Kali because I want to actually get started with Kali first. So Kali is still loading. And again, based on the amount of system resources you have, you do not need to have all the virtual machines running at the same time. You can just run both of them. So you can run Kali and the operating system you're going to be testing on. So we're going to type in the credentials here for Kali, and we're going to let that start up. And I'll just open up a terminal. We'll check if the other boxes are started up. All right, so Metasploitable 3 is started up, and as you can see, it's running on Windows Server 2008 R2. And to log in, it's going to ask you to press Control Alt and Delete. And to do that, you're going to go into your input settings and keyboard and Control Alt Delete. You then want to click on the Vagrant user. So that is going to be automatically set up. Do not be worried. This is how this virtual machine is set up. The password for the Vagrant user is Vagrant, right? And you may have noticed that we have an administrator user. We do not know the credentials to the administrator user, and that's because, as I said, this virtual machine is set up to be intentionally vulnerable, to teach you how to exploit a Windows system, and you'll be able to actually get those credentials at the end of the exploitation process. All right, so that is set up. We now want to check out Windows 7, which is also set up. And as I said, all my versions are activated. Yours do not need to be activated. The reason mine are activated is because I'm going to be demonstrating. I am going to be using the operating systems for demonstration. I need to be in tune with Microsoft licensing terms. All right, so let us check out the various IP addresses that have been assigned to these boxes now that they're on the same network. And I'm just going to use bash here. And I'll say ifconfig on Linux, and you can see it tells us that the IP address is 10.0.0.4, right? And you can actually take a look at the netmask, which is set up correctly, and that's perfectly fine as well. And yeah, that's for the Kali box. So the Kali IP address is 10.0.0.4. Let's check out the Metasploitable 3 IP. So type in ipconfig. And that is set up as 10.0.0.6, 10.0.0.6, there we are. And the default gateway is set up as 10.0.0.1. For Windows 7, let us check this right now. I'll just open up a command prompt here and type in ipconfig. And this is running on 10.0.0.5. So again, because we have the DHCP server set up, that means that these addresses are going to be assigned automatically. You can also assign the addresses manually. You can also then disable DHCP if you want a static network. So what we can do now is we can use Nmap. So again, we say Nmap, we can type in Nmap SN to perform a ping scan, and we can say 10.0.0.0/24, and we're essentially just going to perform an entire network discovery scan here that will actually see if we can communicate with all the devices on the network. And immediately you can see we're looking for the VirtualBox network interface cards here. 10.0.5 is Windows 7, 10.0.0.6 is Metasploitable 3, and our Kali OS runs on 10.0.0.4. So that's a good sign. That tells us that we are able to communicate with all the other virtual machines on this network. Again, you can use a tool like NetDiscover for network discovery, and if I specify my interface name, which is Ethernet 0, you can find your interface name by typing in ifconfig, like so, and you can find that right over here. So this is Ethernet 0. So again, I type in NetDiscover Ethernet 0. And that is going to start performing the scan. Now, don't worry if the actual network address here is different from the one we set up. We're using NAT, which means it's network address translation, which means we'll actually be able to discover any hosts on the actual network that we're running on. So we're going to give this a few seconds so it goes through the entire subnet here and all the class B and C networks. And we'll just give this a few seconds. So I'll just get back to you when we've discovered all the devices or all the VMs that are currently on the network. All right, so the scan is complete, and as you can see, it tells us what we already know. We have, of course, apart from our Kali operating system, we have two. We have Windows 7 Metasploitable 3 that are currently detected here. So the address is 10.0.0.5 and 10.0.0.6. Now, again, if you want to specify your own range when using a tool like NetDiscover, you can easily do that by typing in NetDiscover. And we specify our interface, which is going to be Ethernet 0, and then the range. So we say 10.0.0.0/24. So that's the entire network range. And this will make the scan a whole lot faster. So you can actually see, because it's only going through that entire network range, you can see it's already finished, and it should list out the devices that are currently online. In this case, it's currently telling us that we did not get any results. So it's not actually returning any results. So we'll just give that a few seconds. All right, so the scan is complete, and as you can see, that that actually completed quite quick, and it now gives us all the IP addresses in ordered fashion. So we have our Windows box right over here and Metasploitable 3 box, and we now know that all the machines on the network can communicate with each other successfully. All right, so now that we've taken a look at how to set up our virtual hacking lab, we're now going to be taking a look at setting up the various tools that we're going to be using, and the tools that are tailored towards, Windows penetration testing. So I'll be seeing you there. Hello everyone, in this video I'll be showing you how to set up your Windows 10 VM, which is fairly simple. Now, given that Microsoft has deprecated all previous versions of Windows and all their VMs, the only version that's currently available is Windows 10 Enterprise, and that is under developer.microsoft.com, under English US, Windows, Downloads, and under Virtual Machines. And again, the various packages that are available are for all the various types of virtualization software or hypervisors that are currently out there. We have VMware, Hyper-V, VirtualBox, and Parallels. And the downloads are about 20 gigabytes. Now, we will be using Windows 10, Windows 7, Windows Server 2008 for this course, and we'll be using them to different extents, basically to demonstrate the nuances based on the different versions of Windows and how things change in terms of exploitation and privilege escalation. And you can then download the version that suits you. I would recommend downloading the VirtualBox version, and again, it gives you some basic information regarding this version of Windows. And again, it gives you an expiry date that you can actually keep track of. And again, this is totally free, given that this is a trial version of Windows. Now, in my case, I already have set up my Windows 10 virtual machine, and I'm currently using a licensed version. Again, primarily because of the reason that was mentioned in the earlier videos. I'm currently using this version of Windows for demonstration, and that requires me to have an actual license as opposed to a trial version. So again, just make sure you download the VirtualBox image right over here, and again, it'll simply be an OVA file that you can then run and set up Windows that way. Ensure that you have it enabled on your virtual hacking lab network. So you can see I have Windows 10 Pro right over here. If I go into my settings, ensure that you have it on a network, and make sure that it is set to your NAT network under virtual hacking lab. I'm going to enable that right now. And make sure that is the same for your Windows 7 boxes and any other boxes that you have running. In my case, Windows 7 Enterprise. And we also have the Metasploitable 3 box right over here. That being said, that's going to be it for this video, and I'll be seeing you in the next video.
Did you know that you can be part of the lucrative cybersecurity industry? Even top companies like Google, Microsoft, Amazon, IBM, Facebook, and Dell all hire cybersecurity professionals. The cybersecurity industry has a 0% unemployment rate. The average salary for an entry-level cybersecurity job is about $100,000 per year in the United States. Furthermore, you don't need to know coding and learn from your home, and you get a scholarship to kickstart your career. Apply now. EC Council is pledging a $3.5 million CCT scholarship for cybersecurity career starters. Scan the QR code on the screen to apply for the scholarship. Fill out the form.
Hello everyone, welcome back to the Windows Pen Testing Essentials course. In this video, we're going to be taking a look at host discovery with Nmap. Now, in the previous section, we actually took a look at how to create our virtual hacking lab, which is a NAT network. And we very briefly took a look at how to actually perform host discovery with a utility called NetDiscover. However, we're going to be using a very powerful tool called Nmap, which allows us to perform a variety or a plethora of things or tasks in regards to scanning our network. One of them is host discovery. Now, in the following videos, we'll talk about performing service version detection, operating system detection, scanning for vulnerabilities, etc., etc. Now, the current virtual machine we're going to be using in this particular module is going to be Metasploitable 3. And we're going to be scanning it, and I'll be showing you how to perform the various types of scans with Nmap. So this video is going to be focused on host discovery, which is really simple. So our job now is to actually discover what IP address the Metasploitable 3 virtual machine is on. Now with Nmap, you can pretty much run a variety of scans to test if the device is online, but the one I'm going to be showing you is the ping option. And of course, you can also run the don't ping option, which is great if you don't want to perform host discovery, but you want to perform discovery by actually performing a port scan, which I don't recommend if you're still in the scanning phases. So again, to perform our scan, all we're going to do is type in Nmap, and I'll then say SN, that is the ping option. And then we provide our network IP address or subnet, and we can specify individual IP addresses. So for example, I can say 10.0.0.1, which is the gateway, the default gateway or the router IP address, and we can hit enter. And you can see it will tell us right over here, Nmap scan report for the IP. The host is currently up. Now you can see the very important thing with the ping only option is it does not perform port scanning, which is very important. So that means that this is going to be very useful and effective for scanning targets and discovering whether they're currently online. So to scan an entire network subnet, we simply say Nmap SN /24. That was the subnet that we had created, and again we can specify the actual subnet range, or we can specify the range of IP addresses. So I can say 10.0.0.1 to 255, and that'll scan the entire range of 254 IP addresses, whereas also for using the /24 option will scan the 254 IP addresses. So this is going to scan our virtual hacking lab network. We're going to hit enter. We're going to give that a few seconds, and there we are. You can see immediately we get our results, and with the ping scan, it is only going to perform the scan. It's only going to display the actual devices or the hosts that are currently up. All right. So for example, we have the default gateway or the router. I mean, it tells us that that is up. We have the DHCP server running on 10.0.0.2, which is also up. And then, of course, we have 10.0.0.6 and 10.0.0.9. Now, if we check our current IP address, at least in my case, you can see that the Kali virtual machine is currently on 10.0.0.9. So that means that the Metasploitable 3 virtual machine is currently active on 10.0.0.6. All right, so what we're going to do now is I'm just going to take you through how you can also run the don't ping option, which again is very useful if host discovery is being blocked by a firewall or by a packet filtering system. All right, so what I'm going to do is I'll just clear that out, and we will try the same now. But since we know the IP address of the Metasploitable 3 virtual machine, all we do is we're going to say Nmap, and we use the PN option, so that is uppercase P and lowercase n, and this is going to avoid any type of host discovery. Remember, it's not going to check if the host is up, it's going to start targeting ports. So we're going to say PN, and we're going to specify the IP, and I'm just going to hit enter. So we'll give that a few seconds, and the way this works is it's going to perform a simple TCP scan on the ports, and you can see right over here it performs the actual port scan, and it tells us right over here at the bottom, Nmap done, one IP address scanned and one host is up. And of course we know that it's up, so it's going to scan 1,000 of the most common ports that you typically find, and immediately it gives us the port, the state, and the service. So we can see we have port 21, 22, port 80 running, so FTP, SSH, and HTTP or a web server running respectively. So again, now that we've established what IP address the Metasploitable 3 virtual machine is on and what IP address it is actually assigned to, we can now move on to the next step, which will involve performing service version detection, operating system detection, etc., so that we can learn more about our target. Hello everyone, welcome back. In this video, we're going to be taking a look at service version detection, operating system detection, and how to perform various types of port scans with Nmap. Alright, so now that we've established what IP address our Metasploitable 3 virtual machine is running on, we can now start trying to probe it for more information so that we have a better understanding of what we're dealing with. Now, as I said, we already know that the device is up, and we can now begin with our first step, which is performing port scanning on the target. So if I run a default Nmap scan, which is simply typing in Nmap and the IP, so that's 10.0.0.6, and I just hit enter, what this scan does, it will scan 1,000 of the most commonly used ports. And when we talk about TCP ports, we have about 65,535 ports in total, and what this scan will do is it will scan for 1,000 of the most commonly used ports. So that's something that you need to take into consideration very, very closely. Alright, so you can see that it'll tell us right over here the host is up, so it performs some form of host discovery based on the responses it's getting back from the ports, because in essence what we're doing is we're sending a SYN packet, right? And if the device responds with an RST packet, or if we don't get a response, again Nmap is able to tell, well, is that host up or not? So you can see we scan 1,000 of the most common ports, and it tells us for the rest, which is 990, these are all filtered or closed. So the results we get back are going to be very similar to the results we got back in the previous scan, because we have pretty much not specified the ports that we want to scan. Now, let's talk about port scanning a little bit more. If I wanted to scan 1,000 or 100 of the most commonly used ports, and I can do that by typing in Nmap, F for, and the F means fast. This is a fast scan in that it reduces the amount of ports that you want to scan. We hit enter, and we'll give that a few seconds. There we are. That took much less time. And again, this can be used to some extent for host discovery, but there we are. We can see that it tells us the host is up, and it scanned 100 of the most common ports, and 94 of them are going to be filtered or closed. The rest of them are open, which are actually listed here. So you can see that included in some of the most commonly used ports are going to be, really common services like FTP, SSH, a web server running on port 80 or port 443. You also have an HTTP proxy running on port 8080, so on and so forth. So that is how to specify 100 of the most commonly used ports. Now, if we want to specify a custom range of ports, we can also do that. So if I say Nmap, and I say something like, I can use the P option, so that is -P. I can specify a single port, so I can say I only want you to scan port 22, and I hit enter. You can see it will tell us the host is up, and it only scans that particular port. Now I can also specify a range of IPs or more than one IP, so I can say port 22 and port 443, right? Which again we can test for. And you use a comma to separate the ports that you want to scan. I'm going to hit enter. Again, we'll give it a few seconds, and there we are. You can see it tells us that port 22 is currently open. However, port 443 is currently filtered, and that could be by through a firewall or a packet filtering system. And essentially that means that it's filtered or closed, which means we really do not have direct access to it, or we can't communicate directly with it. And that's of course the conclusion that Nmap has come to. So you can do that, or you can specify a range of ports. So I can say I want to scan ports 21 to port let's see 8080, right? So I want to scan all ports between port 21 and port 8080. You can use the hyphen or the minus key or the symbol here to specify that, and we hit enter, and of course it's going to scan all of those ports. So we'll give it a few seconds. Alright, so the scan completes, and it gives us the results we were looking for. So you can see it scanned all the ports, which was something you can see about 8,060 ports between port 21 and port 8080, and it gives us all the results right over here. So again, we're getting an idea of what's running on the target. But what if we wanted to scan all 65,535 ports? Well, how would we do that? We can specify port 1 to 65,535. However, what we can do is we can use the -p- option, which means scan all ports. So what we're going to do now is we're just going to enter and let's see what it gives us. All right, so the scan is complete, and you can see that it scans all 65,535 ports, and it tells us that out of those, 65,519 of them are filtered or closed, and it displays the rest of them to us, which is again very, very useful because now we understand entirely what we're dealing with in regards to the services that are running on the target. So now that we've talked about port scanning and how to specify various ports, let's talk about how to enumerate more information from the target. So one of these pieces of information that we're after is the service version that's running. And the service version or the service banner gives us the exact version of the piece of software that is running on each of these ports. For example, if we have an FTP port running or the FTP service running, we want to know what version of FTP is running, and that helps us as pen testers because we can search for potential vulnerabilities or exploits that exist for that particular version, and that helps us understand how to target, how to approach the actual target, and what exploits to use, so on and so forth. And then another piece of information that we're after is what operating system is running on this target, and Nmap can do all of that. So to do this, all we need to do is type in Nmap, and we can specify, we can combine commands or options with Nmap. So let's say I wanted to scan, let's see, I only wanted to scan, we want to run a default scan that will only scan 1,000 of the most common ports. So we'll say Nmap. And to scan the service versions, we use the -sv, and the S is lowercase, the V is uppercase, and then we specify the IP address. Like so, and we hit enter. All right, so we're just going to let that give us all the service versions that are currently available. Now, this is going to take longer than a typical port scan because now Nmap is actively trying to probe the actual device, and it's trying to get all the relevant banners so that it can actually again understand, or it can actually deduce what versions are running on those particular ports. So again, we'll just let this scan, and I'll get back to you when this is complete. All right, so the scan is complete. You can see it took about 122 seconds, so it's going to take significantly longer, primarily because it's going to try and probe the target more, as I mentioned. So if we take a look at the results now, they're going to be vastly different than the results we got earlier, where we only had the port, where we only had the port, the state, and the service. Now we have the port, state, service, and the version. So that's the additional column that's added here. Now, given that we only scanned 1,000 ports, it's only going to display those results. So you can see, for example, on the FTP port, we have Microsoft FTPD. All right, so now we understand, firstly, that we are running a Windows box directly from that, and it's running FTPD. Really did not get much information out of that. But for example, on the SSH port, we can see we have OpenSSH 7.1. So that can be used again for vulnerability scanning, and we can then potentially find exploits if they exist for this version of OpenSSH. You then have the web server, which is running Microsoft IIS HTTPD 7.5. And then we have custom services like the HTTP proxy that is running Sun, Glassfish, and this is the open source edition. This is version 4. So you can see that's very, very useful information because we can actually enumerate actual versions of software that are running. And then before we actually start targeting the device or performing exploits, we can again structure our attack based on low hanging fruit. So again, these are the actual results returned to us. Now, you can see, for example, here, it tells us that one service was unrecognized despite returning the data, and it actually gives us the fingerprint here. So again, this fingerprint can then be used for future analysis to try and understand what actual service was running here, because Nmap was not able to come to a conclusion as to what was running. All right, so that is service version detection. And again, you can run this. It is recommended that you run this scan on all ports so that it is as comprehensive as possible. So again, we can then use the -p- option. Now let's talk about operating system detection. All right, so the operating system detection is very simple. all we need to do is specify O. So that is a uppercase O, so minus uppercase O, and we'll also include it with service version detection, and we are going to then perform the scan on all the ports, and we are just going to hit enter. So again, it's going to tell me that right over here, so TCP IP fingerprinting for the operating system scan requires root privileges. So if you're a non-root user, you want to make sure you use the sudo command. So I'm just going to hit enter, and it's going to ask me for my password. I'll just paste that in, and the scan is going to complete now. It's going to start now, and I'm just going to wait for this to complete. All right, so as you can see, the scan is complete and we get the same fingerprint but from before. However, now you can see the results will remain the same regarding service version detection. If we take a look at the bottom here, we have a new section or a new piece of data that's added, and that is operating system details. Now, the way Nmap will do this is based on the responses it's getting from the target. It will come to a conclusion as to what operating system detection, what operating system is running. And of course, it's going to do this through prediction based on the signatures that it currently has stored within its own database or signature file. So you can see that from the operating system details, it tells us that we're running Microsoft Windows Server 2008 or 2008 Beta 3. It also gives us other guesses like Microsoft Windows Server 2008 R2, which we know is actually correct, or Windows 8.1. So typically, this is usually going to be very active in regards to giving you the correct operating system. And again, it gives you a warning, right, if you're telling you that the OS scan results may be unreliable. And that is because we could not find at least one open port and one closed port. So again, it gives you a bit of an idea as to how Nmap comes to these conclusions. Now, as I said, the most important thing to take a look at are the first 2 or 3 predictions, because they are going to be they're going to be the most correct, or the ones with the highest probability of being the actual operating system running. So in this case, we have a pretty good idea that is running Windows Server 2008. And of course, given that we know Metasploitable 3, we know that it's currently running Windows Server 2008 R2. All right, so that's something that you want to take into consideration. But you can see we have immediately performing just 2 scans, we have been able to get a ton of information from our target. And now that we performed a comprehensive port scan, or that we scanned all the ports, we now have a pretty good idea of what's running on the actual target in regards to service versions and the current open ports. And we also know the operating system that's running, which means we can then start performing or looking for exploits that are targeted or are designed for these particular versions of Windows Server. And of course, we can then target the services. We'll be looking at all of this in later modules of the course. Now, before I actually close off this video, or I end off this video, I just want to take you through some very, very useful tidbits or tips that you can use with Nmap. And one of them that's going to be extremely useful is the ability to output your results into a file. So for example, I'll just head over to my desktop here. And if I open up the man pages for Nmap, and that can be done by simply typing in man Nmap, and I scroll to the bottom here, you can see that if we go right at the bottom to the output here, you can see that we can output our scans to different types of files. And we have a normal output, which is going to be displayed exactly how it displays it onto the terminal. We have XML format, and we have the script-kiddie format and the greppable format. The 3 most important formats you're going to be using are going to be normal, XML, and the greppable format, which can then be used with a command line utility like grep. And you have all the options here. So for example, if I wanted to output the file into a normal file, I would use the ON option. If I wanted to output into an XML file, I can use OX. And XML files are useful if you want to parse the information into a web page or into a report. And then, of course, you have the OG option, which will output into a greppable format. So, for example, if I wanted to output a simple scan, so I'll say Nmap F, I only want to scan 100 of the most common ports, and I want to perform some service version detection. You can see how I'm combining scans here. It really is fantastic that you can do this with Nmap. And then I provide the IP here, and then I say ON, so that is a minus lowercase o and a uppercase n, and then I specify the actual file name. So I can say nmap.txt, right? If I wanted to output into all formats, I can then simply type in OA and that'll output it into all file formats. So I can also do that as well. And then I get rid of the extension here and I just give it a file name. So I just call it nmap scan and I just hit enter, and that is going to perform the scan, and it's then going to output this scan into these three formats or 3 or 4 formats that we can actually use for generating reports. We can use it for reference or to access later, so that we don't have to keep on running our scans to actually analyze the results time and time again. All right, so again, we'll just let this run. All right, the scan is complete, and again, it'll display the information to us on the terminal. But if we list out the files in our current directory, you can see that it outputs into the greppable format, which is gnmap, and then it outputs into the normal nmap nmap output format, and then we have the XML file. So if I cat the contents of nmapscan.nmap, you can see it actually displays exactly what we got on the terminal. So this is again just human readable information. You then of course have the XML output, so I can just say nmapscan.xml, and you can see that that is indeed in XML format, which again is very useful for generating reports or for parsing it into the web or into a web page. All right, so that is how to actually specify your output options. And again, I'll just take you through some other really cool features that you can use with nmap. All right, so what I'm going to do now is we'll just run the same scan that we ran before, and let's talk about verbosity in terms of what is outputted to you on the screen. So when we talk about what is output to us on the screen, you can see that when we hit enter without specifying the amount of verbosity, nmap does not display anything to us, any diagnostic information to us as the user. If we want nmap to actually display and to actually state what's going on in the background before it actually delivers the results, we can use the -v option, and that is lowercase v. So that is level 1 of verbosity. We can also use level 2 and level 3 to give us more information. So again, if we can run that command the way it is. However, if I just open up the man pages and I grep and I say I'm looking for let's see, let me just use the expression option, and I'm looking for verbose, right? So I can say verbose, hit enter. You can see that if we take a look at the man pages, we use the normal output in verbose, we use the V option here, and then if I look for verbosity and just hit enter, you can see that we can increase the verbosity level by using more V's. So we can specify more V's. So again, you can also do this by specifying V1, V2, V3, etc. In my case, I really like using just 1 or 2 V's. It just gives me just enough diagnostic information that I need. So again, I can just hit enter. And now you can see it's actually displaying what's going on in the background and how nmap is coming to its conclusions, and the results are being delivered to us live. And then once the scan is done, it'll give us the information that it actually was able to get. So you can see right over here, it starts the DNS resolution and then completes parallel DNS resolution, and then it initiates the connect scan, the TCP connect scan. And you can see it discovers an open port on port 8080. It discovers an open port on port 80, port 22, port 21, so on and so forth. And then it's going to move on to the next stage, which is service version detection. So it actually runs the scan chronologically or in order. So you can see, first of all, it actually performs some host discovery. So it initiates a ping scan. It then performs your parallel DNS resolution. It then goes on to scanning for ports, which is we specify the F option. So only 100 of the most common ports. We then move on to service version detection. So it's going to scan 6 services, and then it's going to essentially going to output the results to us. And immediately it did that for us right over here. So now we have an additional column that is called the reason column, which actually tells us the reason it was actually able to come to these conclusions. In this case, we got a SYN-ACK in return. This particular scan utilizes a TCP connect scan, which again will typically utilize the TCP three-way handshake, where nmap will send a TCP SYN packet, and then based on the response, if it gets a SYN-ACK, it means that particular port is open. If the port is closed, it will get an RST or a reset packet telling nmap that is closed. So again, that's just a few tips that you can use in the event you want to learn more about nmap, or you're trying to understand what's happening behind the scans or in the back end. That being said, that's going to be it for this video, and I'll be seeing you in the next video. Hello everyone, welcome back to the Pen Testing Essentials course. In this video, we're going to be taking a look at how to perform firewall detection and evasion with Nmap. Now, as I mentioned in the previous section, we are going to be dealing primarily with Windows systems, and one thing that all Windows operating systems, whether we're talking about Windows Server, Windows 2000 and Windows 2008 to 2016, 2012, or we're talking about desktop editions or Windows 10, Windows 7, Windows 8.1, all of them have one thing in common, and that is they have Windows Firewall in place, right? Now, Windows Firewall can be, again, an issue depending on the way it's configured. Now, the first thing we need to do as any pen tester is we need to understand if we actually have a firewall running and if the firewall is active. And the easiest way we can do that with Nmap is by running or by performing an ACK probe scan. Now, an ACK probe scan works very differently. It works very differently and counterintuitively to how the default TCP three-way handshake is initiated and again how it is completed in terms of the sequence. What we're doing now, instead of sending your simple SYN packet to your target, we're now going to send a packet with only the ACK probe or the ACK flag set, and doing this will allow us to determine whether the target is actually being filtered by a firewall, or whether it's being protected by a firewall, or whether it really is not being protected by a firewall, or the firewall isn't active. And we can easily run this on any target. And what I'm going to do now is I'll open up the Metasploitable 3 virtual machine here, and I will just open up Windows Firewall here. So I'll say Windows Firewall, and we'll open up, there we are, and we will say I want to turn Windows Firewall on or off. So I'll turn it off just for a second. I just want to show you something. So I will turn it off, and I'll open up my Kali virtual machine again, and we'll run the ACK probe scan. So we say Nmap, and we can specify the ports that we're interested in, but in this case I'll just leave it to the default. So I can say Nmap, and we say SA, so lowercase s, uppercase A, and the target IP. We hit enter. It's going to say we require root privileges, so I'm just going to provide them. And there we are. I'm just going to hit enter, and again we'll just let the scan complete, and you can see immediately it tells us that the host is up, so it performs host discovery. We then can see that it tells us all 1000 scanned ports on the target are unfiltered. So that means that all 1000 ports are not being protected or are not being filtered by a firewall. All right, now that's because we've disabled the firewall. But just to prove to you that this scan does work, I will reactivate the firewall. So I'll open up Metasploitable 3 here again, and I'll say turn Windows Firewall on or off. I'll turn it on for both public and private networks, and I'll just hit OK here. And we'll go back into Kali, and I'll run that one more time just to show you. So I'll hit enter, and we can compare the results. You can see for one, the actual scan is taking longer, so that's an indication that something has changed. So again, we'll just let the scan complete here. So there we are. It should take just a few more seconds. Again, it's going to take significantly longer than the actual than a scan where you don't have a firewall in place. But again, this is one of the great things about Nmap, is the ability to detect whether we have a firewall up or not. So you can see in this case, we now get the same scan results. The host is up, but instead of telling us that the ports are unfiltered, we can now see it tells us that all 1000 scan ports on the target are filtered, which means there is a firewall in place, and this may hinder your scans. All right, so now that we've taken a look at how to detect firewalls with Nmap using the ACK probe, we can now take a look at some common firewall evasion techniques. All right, so let's get started with that. So the first thing we are going to be taking a look at is one of the most common techniques that has been used for quite a while, and that is the ability to actually fragment your packets into smaller 8-byte packets, right? So to do this, all we need to do is we need to say, if we are running a simple scan here, we can say fragment, and we can use the minus lowercase f, that means fragment, and this will fragment it into 8-byte packets. And of course, you can analyze this yourself. And again, the whole idea behind reducing the size of the packets is to fragment a packet so that when it's passing through a firewall, the firewall is not able to detect what's actually being sent to the target, because it's all in fragments, as opposed to a single packet that contains information that the firewall might flag as malicious, right? So if we say nmap f, and we can then, you know, specify our own types of scans like nmap f sv, specify a fast scan here, and then we can type in the target IP here. So I say hit enter. Again, you can see it's going to tell me the frag scan requires root privileges, so I'll just hit sudo and I'll just hit enter now one more time. So again, we'll just let that run. Now, one of the issues that you'll have with fragmentation is fragmentation was really used on older firewalls. So again, it can be used on a few old legacy Windows systems. It also is very effective. I've tested this myself on Windows Server 2008 system, so you can use this again for very basic level of evasion. So again, we're just going to let this scan run, and then we're going to take a look at performing a SYN scan, or a stealth scan as it's known. And then we'll also talk about decoys and specifying your MTU as an additional option as well. All right, so as you can see, we get our results back, and again, we get the exact same results we would have gotten. And again, the fragmentation really didn't make much of a difference apart from slowing down the scan, because remember, we're fragmenting the packets into smaller pieces, which means the requests are going to be fragmented, and then they need to be sent to the target, where they're reassembled and then interpreted, and then a response is sent back. So again, that is fragmentation in a nutshell. It's a very basic technique that's used. Now let's talk about one of the most important types of scans, and that is your SYN or your stealth scan. If I just clear up my terminal here, so I'll say man, and I'll say man nmap, and I hit enter, you can see that I'll look for the SYN scan, and we're looking for the first option that is denoted by a -s, one lowercase and uppercase s. So the SYN scan is the default and most popular scan option for good reasons. It can be performed quickly, scanning thousands of devices as stealthily as possible, because it never completes TCP connections. All right, so this is the de facto scan that you should be running, primarily because it scans very quickly, because it is essentially splitting the TCP three-way handshake in half. And secondly, it's going to be extremely stealthy, because a firewall is looking for, it's looking for the complete TCP three-way handshake. And if you cut it in half, then it's really not going to be able to detect what's going on exactly, because I'll explain it to you very basically. What's happening is instead of completing the TCP three-way handshake, where you send your SYN packet, and then you wait for a response from the target, which could either be a SYN ACK if the device is up, and then you respond with an ACK. What we're doing here is we're sending a SYN, and then we wait for a response, and then irregardless of the response, we simply send a reset packet back to the device, and we're essentially splitting it in half, making the scan shorter and stealthier. To run this scan, all we need to do is type in nmap ss, so again minus lowercase s and uppercase s, and then we specify our ports. Again, I'll just use the 100 most common ports, and we can then specify our target or any other options that we would like. So for example, I can say I want service version detection and a bit of operating system detection, so 10.0.0.6, and we can then hit enter. So what I'm going to do now is I'm just going to demonstrate this to you with Wireshark, right? So Wireshark is a traffic analyzer and inspector. It allows us to analyze packets being sent and received from our target, and I'll just specify my Ethernet 0 interface here. So I'm just going to start the scan, and it's going to say it requires root privileges, so I'll provide that with root privileges here. So sudo, we're just going to hit enter, and if I open up Wireshark and I start the capture now, you can see we have all of these SYN packets being sent to the target. So again, I'll just wait for the actual scan to complete. Let's see if that's actually running here. There we are. It's running, and I'll just try and zoom in here. Let me just try and zoom into the actual traffic being captured. There we are. So I can now spread this out, and I'll just say I want my info right over here. So you can see we are sending our SYN packets right over here, SYN, SYN, SYN. We then get a SYN-ACK back from the target. You can see the IP 10.0.0.6 is the source and the destination is our IP. We get a SYN-ACK. So that means that these ports are going to be open. So both port 21 and 22 are open. You can see that's specified right over here. We can also open this up. You can see the source port and the destination port are also listed right over here. All right. So that is how we can actually that is essentially how this scan works, by sending SYN packets. So I just wanted to demonstrate that to you so that you have an understanding. So I'll just close this here. I don't want to save the packets, and there we are. The scan is complete. And because we used the stealth scan, for one, you can actually tell how much faster that scan was, and we get all the results we were looking for. So there we are. We're able to get our operating system detection, service version detection, so on and so forth. All right, so that is how to use the SYN scan, or the stealth scan as it's known. Let's talk about a few other techniques. One of the techniques that I want to show to you, which is really cool, is the ability to use the decoy. Now, a decoy is exactly what it's exactly what it states it is. It is essentially using an IP address or a decoy IP address to perform your scan. So, for example, if we are on a network that we are not supposed to have access to, and we have a firewall running or an intrusion detection system that is running and actively monitoring the network, if we try and initiate a scan on a target that we know we do not have permission to do so, that will be flagged as a malicious activity, regardless of how we actually try and make it as stealthy as possible. So what we can do is we can actually use another IP or another set of IPs as decoys to actually trick any intrusion detection system or firewall into thinking that the scan is coming from another IP address, which is absolutely brilliant. So to do this, we have multiple ways we can do this. We can actually, again, specifying it is very simple. So again, if I wanted to say nmap, and we can run any type of scan that we want, we can say nmap, we want to run a stealth scan, and we want to run it on all 100 most commonly used ports. If I want to use a decoy, I use the -D option. Now, when we talk about specifying a decoy, we can specify random decoys. And to do this, we can say RND, sorry, that is capital RNDs for random. We then use the colon, and we specify the amount of random IP addresses that we want to use, and Nmap will generate them automatically. This is great, and I'll show you why in a second. So if I say I want to use only 3 random IP addresses as our decoy, and we specify the target IP here, I'll open up Wireshark just to show you that 3 other IPs are using apart, and these are not going to be our IP address or our Kali Linux IP. So again, I'll open up a new tab here, and if I list out the IP address of the Kali virtual machine, you can see the IP is 10.0.0.9. So just keep that in mind as we run this scan. So again, I'll just start the capture and I'll hit enter. It's going to tell me it requires root privileges. I'll provide it with those root privileges. And we'll just capture a bit of traffic here. The scan is complete, and we'll stop the capture. So if we go to the top here and we take a look at the SYN requests being sent, you can see that the source IP address is not our IP address at all. It's going to be these 3 IP addresses that are going to be used. And you can see them being repeated frequently. So for example, you can see the sequence is repeated after every SYN packet has been sent. So it sends one with 208.166.217. It then moves on to 196.162, and then 208.249, and then it repeats again. So 208.166, 196.162, 208.249. So you can see that really is brilliant, because we can mask our activity as other IP addresses, which is great. So if you're on a private network that, again, you want to be as clandestine as possible, you can also make it look like the scan is coming from an authorized system on the network. So for example, if there is an administrator on the network, you can actually spoof their IP address to make it look like the scan is coming from their IP address, which is brilliant. So again, we can do the same thing. We say nmap, and I'll say we want to run a stealth scan. We're going to run it on all 100 most common ports, and we can then specify our decoy, and then we specify the IP we want to use as our decoy. In this case, let's make the scan look like it's coming from the actual access point or the gateway or the router IP address. So you can say 10.0.0.1, and then we specify the actual IP address of the target, 10.0.0.6. I'll hit enter, and again it's going to ask me for root privileges. I keep forgetting to provide it with root privileges. We will start a new captcha here, so continue without saving, and I'm going to hit enter, and we let that go. We'll let that continue scanning, and there we are, the scan is complete. And you can see right over here it keeps sending its SYN packets with the source IP of 10.0.0.1. and again, it really is brilliant that the fact that you can actually mask your IP address or use a decoy IP address to make it look like the scan is coming from another device on the network or another device that is on the internet or that is not part of the network. Really is brilliant. So these are the tactics primarily that I wanted to show you in regards to firewall detection and evasion. So that's pretty much going to be all that I wanted to cover in this video, and I'll be seeing you in the next video. Hello everyone, in this video I'm going to be taking you through how to perform service enumeration with Nmap scripts, or the Nmap scripting engine for that matter. So let's get started. The first thing I want to take you through is of course performing a default Nmap script scan. So again, what I can do is I can just open up the Nmap man pages, and the reason I'm doing this is because I want to explain a few things. So I can just actually just open it up directly because I know the actual location of what I am going to be taking you through. So if we take a look at we've already taken a look at host discovery to a certain extent, and we're going to be taking a look at the script scan. So there we are. You can see that we have the SC option. So that is minus lowercase s and uppercase c. This will use the default Nmap scripts within the default Nmap script directory. Now, when we talk about Nmap scripts, let me explain what they are. If we go onto the Nmap website, that is at nmap.org, under the book, and we have the manual page, you can see that the Nmap scripting engine is one of Nmap's most powerful and flexible features. It allows users to write and share simple scripts using the Lua programming language to automate a wide variety of networking tasks. These scripts are executed in parallel with the speed and efficiency you would expect from Nmap. And again, these scripts are used to perform a wide variety of networking tasks, as they've just mentioned here. So the type of functionality that you can do are defined, or the type of functions that that a script can do are defined in terms of categories, and the categories are auth, broadcast, default, discovery, DOS, exploit, external, fuzzer, intrusive, malware, safe, version, and vuln. All right. So you can open up the script categories to actually take a look at the various categories of scripts that you have. Now, when we take a look at the default script category, you can see that these scripts are the default set and are run when the SC option or the A option, which is the aggressive scan, is invoked. And again, that allows you to run the default category. Now, this is typically what you'd run by default, and I'll be taking you through scripts manually and explaining how they work and what they can do. Now, when we talk about Nmap, your scripts are typically going to be stored under your user share Nmap directory under scripts. So if I hit enter, it will display all the scripts that are currently available to us that we can use. Now, these are not going to be sorted into functionality, rather the protocol or the service version they are associated to. So for example, if we say we have various SMB scripts here, you can see that this SMB script will check for SMB2 capabilities, and it has the extension NSE. Now, these scripts are again programmed in the Lua scripting language. So that means you can actually take a look at these scripts, you can interact with them, you can develop your own, so on and so forth. And mainly scripts are just used to automate things that you typically do manually. And again, with the various categories, these scripts can do a lot of things, from performing authentication to performing brute forcing, performing exploitation, testing for certain vulnerabilities, so on and so forth. So for example, we can scroll all the way to the top here. You can see we have various HTTP scripts that scan for particular vulnerabilities, and the various CVE codes are listed here. so on and so forth. So again, using these scripts is very simple. If we talk about the basic usage first, we can invoke the default category of scripts to be run by typing in nmap and then using the SC option, right? We can do that. Or we can use the A option. Now the A option refers to an aggressive scan. Now an aggressive scan combines three types of scans together. The aggressive scan combines the service version detection, it combines the aggressive scan, and then combines the default nmap script scan. So this is an extremely comprehensive scan to use, and all you need to do is specify the A option. So we can actually do that, and that will combine service version detection with operating system detection, that is operating system detection, and the default script scan right over here. So again, we can just use the nmap A option, and we will combine it with the SYN or the stealth scan, and then we can provide the ports. So we'll just run it again on the 100 most common ports so that we don't have to waste any time, because when we include additional type of options in our scan, like the script scan, it's going to take more time. We'll talk about timing in a later video. So we can then provide out the IP of the target here. So I can say 10.0.0.6 and we hit enter. It's going to say we require root privileges. We're going to provide it with root privileges. And again, we're just going to wait for this scan to complete. All right, as you can see, the scan completes and we now have a plethora of new information that's being given to us just by including the default script or the default nmap script option. So you can see that in addition to the results that we typically get in regards to the port, the state of the port, what service, and the service version, at the bottom of that particular service, which is again is going to be indented, you can see that we now have new information. So for example, we have FTP syst here. Now FTP syst, this is in reference to the FTP syst script. So it's actually listing out what script was used to scan, and what the FTP syst script does is it actually just displays the actual system that is being used, or the actual operating system on which this FTP server is being run. In this case, it tells us that Windows NT is being used. So you can see that this FTP script is giving us valuable information regarding what operating system is running. You then have the SSH host key script, which is running under SSH, and that essentially just gives us the SSH host key, not really that important information. And then you have the port 80, which is a web server. And then for the port 80 or for the web server, you can see that it runs three scripts by default. It runs the HTTP method script. It runs the HTTP server header, which tells us the actual server header or the server side technology being used. In this case, it's Microsoft IIS 7.5. And then the HTTP title that's being used. In this case, it tells us that the site doesn't have a title. So immediately we're getting tons of more important information regarding our targets. And if we take a look at the proxy, you can see that just uses the HTTP title script here, and that tells us that we have Glassfish server and the server is running. So that is how to use how to use nmap scripts, and I've talked about invoking the default nmap script scan. Now we can also use scripts individually, which is really where I want to demonstrate the power of nmap, because that's where things get really interesting. So again, if we take a look at our target here, right over here, you can see that we have multiple ports and services, and we have multiple types of scripts that we can run. So again, if I list out the scripts within the nmap scripts directory, again, this will list out all the scripts that we can use. And again, we can start using these scripts to enumerate more information from our target. So if we are talking about the web server, for example, I can use the HTTP enum script. And the way I can list out all HTTP scripts is I can grep this, I can pipe and grep and say I want to use an expression. We'll say HTTP, and I can then list out all the HTTP scripts that we can use. Now the script that I want to use in regards to HTTP is going to be the HTTP enum script, and I'm going to be taking you through only the most important one, which is the one right over here. So we want to use HTTP enum. To use a single script, it is important that you know what service you're targeting and what service this script is designed to be run on. So in our case, if I say nmap and I can run a stealth scan, To run a single script, I say script, and that is done using 2 minus or 2 dashes, and then we say script, and then we specify the script name. So HTTP enum, right? And then I specify the target, so 10.0.0.6, and I hit enter. It's going to ask me for root privileges. I'm going to provide it with root privileges. So you can see it'll start the scan, and we're just going to let that scan run. And you can see that this is now going to scan all the default ports, which is exactly what I wanted to point out. So if we are only scanning the web server, it only makes sense that we provide only the web server port that we want to target. So we can say, I want you only to target port 80 and port 8080 because we have a proxy running on port 8080. So I'll hit enter, and now you see the scan is much more efficient because we're only scanning the ports that are relevant, and we're using the script that is relevant to those ports. And there we are. So you can see that for port 80, we don't get any important information. HTTP enum simply lists out the directory of that web server. So you can see for the proxy, it gives us a bit of shellcode here, and it tells us that this particular proxy is vulnerable to directory traversal, which is very interesting. So again, it's already revealing potential vulnerabilities within the system, and that is just by invoking one simple HTTP script. Now, as I said, there's tons of HTTP scripts that you can use. One of my favorite is the ability to test and see if we have a web application firewall running, and you can run this against websites to detect if there's a web application firewall running. You can also use the HTTP WAF fingerprint script, which will actually tell you what web application firewall is running, which is fantastic. Now, as I said, we can take a look at tons of scripts that we can run. As I said, by default, you want to run the default Nmap script scan. However, let's talk about a few Windows type scans. Now, given that Metasploitable 3 doesn't have, again, it has SMB ports running, but we can actually take a look at that shortly. Let's take a look at some of the CVEs or Windows exploits that Nmap scripts that we can actually scan for with Nmap scripts. So if I just clear this out right over here, we can actually scan for a popular vulnerability that again is we can use. So again, if I just open up google.com and I search for a vulnerability called MS08, so 2008, so that's 08, and we say 067, right? So 067, and we just open that up. We'll just open up one of these ones right over here, the Microsoft Bulletin, Security Bulletin, and we can open up Rapid7 here. So again, you can see we can take a look at the affected and non-affected software. You can see for Windows, it affects Windows Server 2008. There we are. So again, this vulnerability affects Windows Server 2008. So we can actually run this particular script. So this script is an SMB script. And so what we can do is we can run the same script here. We can say nmap, we'll run a stealth scan, and we'll say we want to we can also fragment the packets because we're dealing with the firewall. If I disable the firewall for a second here, so I'll just say open up this, and I just disable the firewall because I do not want to cover that right now. I'm simply explaining how to perform these types of scans. So we can say nmap ss, we specify the port 445 for SMB, and then we say script. We're looking for SMB. The script name is SMB vuln. And again, you can list out all of the SMB scripts by listing out the directory of the Nmap scripts here. So list user share Nmap scripts, and we can then pipe and grep this, and we're looking for SMB scripts only. So we can hit enter, and now you can see we have all the SMB scripts here. So the one we are targeting is MS08067. So we can actually just copy that directly if you don't want to type it in, or you don't need to remember them directly. So we just specify the script here, and then the IP 10.0.0.6. Now this is a vulnerability scanning script, which is very important. It is going to scan for a particular vulnerability. So immediately you can see that it tells us it does not give us any options here. So what we can do now is we can actually just get rid of the I'll get rid of the stealth scan. We hit enter again. So again, it tells us that it is not, if it does not give us any results, it means that it's not particularly vulnerable to this particular exploit. So again, we can run this against all our Windows machines that we'll be working with, but I just wanted to take you through the basics of Nmap scripts and how to run the default script scan. And that's pretty much all that I wanted to cover in this video, and I'll be seeing you in the next video. Hello everyone, welcome to this video. In this video, I'm going to be showing you how to perform vulnerability scanning with Nmap using the Nmap Vulners script that comes pre-packaged with Nmap now. I'm currently on the GitHub repository just to give you more information regarding the tool and how it actually does what it does. So as I said, this is going to be focused on vulnerability scanning. So if we take a look at the description of the Nmap Vulners script here, you can see it tells you that this script is it uses the default Nmap service version detection system to get banners, and then it uses those banners to perform scans, or it'll actually scan to see if any of those services are vulnerable to a particular exploit, an exploit that has been publicly disclosed. And then it does that and displays the various CVE codes for these vulnerabilities. So again, if a service is vulnerable to a particular exploit, it will list out the CVE code. CVE stands for Common Vulnerabilities and Exposures. And again, it will list out the actual code here, and then it'll also display the severity in the event that, again, you want to know how to structure your attacks, and then it gives you a relevant link that gives you information regarding when the vulnerability was disclosed, so on and so forth. Now, as I said, this script comes pre-packaged with all latest versions of Nmap, and using it is very simple. We need to run the default service version detection scan and then run the script vulners here and then provide the target. So we'll do that right now. So again, running it, as I said, is very simple. All we need to do is type in Nmap, and then we say service version detection. We want to perform some service version detection, and we can also run a stealth scan here in conjunction with this, and we can then specify the ports that we want. In this case, I'm just going to specify, we'll say ports 21 to port 8080, or we can simply just run the default port scan, which is 1,000 of the most commonly used ports, and then we say script, and then we specify the vulners option right over here. So that's the name of the script. We say vulners, and then we hit 10.0.0.6, which is the actual IP address of the Metasploitable 3 virtual machine, and we hit enter. It's going to ask me for root privileges. I'm going to provide it with root privileges, provide my password, and there we are. So I'm just going to let this scan complete, and I'll get back to you when it's done. All right, the scan is complete, and as you can see, for port 22, which is running SSH, and OpenSSH 7.1, we have various CVEs that are listed here, and we also have their severity. So you can see this is OpenSSH 7.1, and it gives us all the actual CVE codes that we can actually then copy and use for our own research. So again, I can open that up in Google. So paste and go, and that'll take me again to the actual releases. So you can see if I open up Rapid7 here, Rapid7 will give us more information regarding this vulnerability and how to exploit it. So you can see it tells us this is an OpenSSH vulnerability, and again it gives you a description of the vulnerability, and then if there is a Metasploit module, it'll actually list out the Metasploit module that you can use to actually exploit this particular service. So again, it's extremely useful in understanding what actual services that are running on the target are vulnerable to publicly known exploits. And again, the addition of having the CVE code is extremely helpful. And you can see for pretty much the only service that we're actually getting the vulner script successfully running or giving us scripts is the SSH port. And of course, that does not mean that the other services running on the system are not vulnerable to any particular exploit, or are not vulnerable to any openly known exploit. It simply just means that the vulner script was not able to come to that particular conclusion using the banners it was able to retrieve. That being said, that's pretty much all that I wanted to cover in this video, and I'll be seeing you in the next video. Hello everyone, welcome back to the Windows Pen Testing Essentials course. In this video, I'm going to be taking you through Metasploit or the Metasploit framework. So this is just going to cover the fundamentals of Metasploit. So first of all, what exactly is Metasploit? Well, Metasploit is an exploitation and penetration testing framework that is written in the Ruby programming language and can perform everything specific to a penetration test, all the way from scanning and information gathering to exploitation and privilege escalation. So it really does a lot. And given that it is a comprehensive and inclusive framework, when it comes down to penetration testing, you can pretty much perform your entire penetration test using Metasploit. Now, the aim of this video is to get you up and started and running with Metasploit. And I'm going to be doing it with two ways. Firstly, I'm going to be explaining the structure of the framework and how it works, how everything is sorted out, because it is a fairly complex framework in regards to the way it's been developed. It really is very simple to use. And again, because of its complexity and how it's been managed, it really is beautiful to actually see. And I'll be showing you that shortly. So again, the way Metasploit handles its functionality and the complexity is by the use of modules or segregating various pieces of functionality into modules, and that'll become clear in a very short period of time. So we're currently in the terminal, and the Metasploit framework comes pre-packaged and pre-installed with Kali or any other pen testing distribution. So you don't need to worry about installing it. Just make sure your distribution is up to date. The first thing we want to do is let's first of all understand the structure of Metasploit, as I said. So if I list out the contents of, let me just say AL here, and we say the user, share, and we're looking for the Metasploit directory here. So Metasploit, we just use Metasploit framework. There we are. And I list the contents of this directory. And I'll just scroll all the way to the top here. You can see that we have various files, most of which are not really important, but we have various executables like the Metasploit console, which we'll be using shortly. You also have MSF Venom, which is used to create payloads, which again we'll be covering in the next video when we'll be talking about creating payloads that we can then use to get a reverse shell on or a Meterpreter session on. But let's take a look at the modules folder, which is where everything sort of comes into play in regards to the actual framework and what we'll be interacting with. So if I say cd user share, and we go into the modules directory, I'll just clear that out and we'll list them. You can now see this is the fundamental structure of Metasploit and how its functionality is sorted out. So first of all, you have auxiliary modules. You then have encoders, which pretty much explain what they do. They're used for encoding. You then have evasion modules. You then have exploits, which again are pretty self-explanatory. These are used for exploitation. You then have NOPs, payloads, and post, which is for post exploitation. So you can see that within each of these folders, you'll have all the various modules that deal with that particular piece of functionality or that particular function. So if I'm talking about auxiliary or scanners, you can see if I enter the auxiliary folder here and I just list out, you can see they're then further sorted out based on the actual functionality. So again, we have fuzzers, we have scanners, sniffers, etc., etc. I'm not really going to go deep down into the actual structure of Metasploit. I'm just going to show you how this all comes into play shortly. So if we take a look at exploits, for example, you can see that in terms of exploits, they're sorted out in terms of their operating system, right? Or the target operating system or platform. So for example, we have the Android platform, we have Apple iOS, we have BSD, BSDI, we have Firefox, FreeBSD, Linux, we have NetWare, we also have Solaris, Windows, Unix, OS X, all the operating systems that Metasploit currently has exploits for. So again, if we're looking for a particular exploit, we can go into the into that particular directory. We can say, hey, I'm looking for Windows exploits. So enter the Windows directory. You can now see they're now based on a protocol or the service that these exploits are primarily targeted towards. So for example, we have antivirus exploits, backdoors, email, browser, firewall, We have MySQL, MS SQL. We also have PostgreSQL, etc., etc., etc. We have POP3. We have all the various services that are available. So now that we have an understanding of how it structures and sorts out its modules and how it's able to manage that level of complexity, we can actually get started with the framework. So getting started with the framework is really very simple. All we need to do is type in MSF console, and that'll start it up. But before we do that, we need to ensure that if this is your first time running the Metasploit framework through the Metasploit console, all we need to do firstly is we need to ensure that we start the PostgreSQL database service, which comes again prepackaged and pre-installed with Kali. And Metasploit uses the PostgreSQL database to store all the relevant database file names regarding the modules that are currently set up. And this will reduce the amount of search time that you'll actually need when searching for modules. So we use system control and we say start. And we're going to start the service here. So we'll give that a few seconds to start the service, and that should start it. And then we want to launch the MSFDB, or the Metasploit Framework Database. So we can hit enter. You can see the Metasploit Framework Database. These are the options available to us. We can initialize the database. We can reinitialize the database if we so want to. We can delete it, start, stops. We can check the status, and we can run it. So what we can do is we can initialize it. So we say MSFDB. And we say init and hit enter, and it's going to say we need to run it as root. So I'm going to do that, hit enter. It's going to say database already started, creating the database user MSF and creating the database MSF as well. So this will, again, the reason why we have the Metasploit database or the Metasploit framework database is because this database is used to store all the various indexing for all the modules, and you'll see how much faster searching for an exploit or a payload is in a few seconds. So again, we're just going to let the database initialize here, and then we're going to get started with the actual framework, and I'll just take you through some basic options that we'll be using. So there we are. It's going to create the initial database schema, and don't worry if you get any errors. Those are perfectly fine. It really will not cause much of an issue at all. So again, we'll just wait for this to complete. Right, so once the database is initialized, we can get started by typing in MSF console, like so, and that should start up the Metasploit console for us. That way it's going to tell us starting the Metasploit framework console. We'll give that a few seconds, and there we are. So this is the Metasploit framework console, and we can now get started with me explaining all the various options. So again, if I open up the help menu, this will give us some general documentation regarding all the commands that we can run. So this is a great place to start with if you're a beginner. It really does help, and it's a very, very well documented and simply documented so that you really don't need to analyze exactly what it's saying. So again, for example, if I type in banner, it will just display an awesome Metasploit banner. If I, click on connect or get or any of the other commands, it explains exactly what it does. Right. So what I will do now is I just want to show you the typical workflow when you talk about exploitation using the framework. So firstly, if I want to show, for example, exploits, I can simply type in exploits, hit enter, right? And that's going to show me all the exploits, which is not something you would typically do. What you do typically is you would search for the exploit that you're looking for, and I've demonstrated this in the previous modules. However, we'll be taking a look at it even more now. So again, this is going to be a huge index, which is why it's taking so much time, because there's like almost too many modules to actually count in regards to exploits. So you can see we have all of these exploits that are sorted out here. And the key thing to take a look at firstly is if I just reduce the I'll just reduce the font size here so that I can explain a few things. If I search for an exploit, and let's say I know the name of the exploit, let's say I'm looking for Eternal Blue, right? I can search for Eternal Blue. You can see that it's going to give us the matching modules. However, in regards to the modules, you can see that these are going to be different modules, and they are structured as followed. So again, you need to also understand the directory structure, which I explained. So at the top level, we have auxiliary modules, which are used primarily to perform scans. So you can see this is an auxiliary module of type admin. It's an SMB module, and it's based off the MS17010 command execution exploit, right? And it just gives you information regarding that particular module. So in regards to the auxiliary scanner, you can see it right over here. So this is an auxiliary module and it's of type scanner, and it's based off the SMB protocol, and it's of this particular exploit, the SMB MS17010, and this is used to check whether a system is vulnerable to the eternal blue vulnerability. Right, you then have the ones at the bottom here, which are all exploits, because you can see this is an exploit, and they're based on Windows, SMB. They're essentially based on the MS17010 exploit. So this one right here is primarily designed to work on Windows 7 systems and older. You then have this one, which is designed to work on Windows 8. You then have, of course, your PSExec right over here, and then you have your remote code execution. And in regards to the disclosure date and the other columns, you can see that the rank is going to be very important, because the rank essentially tells you the actual effectiveness of these particular modules in regards to the results that you're likely to get. Now, you can pretty much search for the modules you're looking for, performing research and stuff like that. And then once you've identified the module that you want to use, you can simply just copy the name here. So you can just say copy selection, or you can type it out for yourself and just hit use, and we say use, and we essentially paste that name here, the module name. And you can now see that when you've selected a particular module, it will say it's an auxiliary module, and then it gives you the actual module right over here, and that's going to be highlighted in red. Now, when you've specified a module, you can show the various options associated with this module. So if I say show options, it will give you the various options that you can set for this particular module, which in this case is an auxiliary module. So for example, we can set the command to run, we can set the SMB domain, SMB password, the SMB share, etc., etc. I'm not really going to get into this too much. I just want to explain how this works. And then when you want to run the exploit or that particular module, you just type in run. And of course, in this case, it's going to tell us that the auxiliary failed because we did not enter our target address, which is fine. So if we want to set an option, in this case, it's telling us we need to set our rhosts option, which is our target. We can say set, and we type in the actual option name. So if I'm setting the rhosts option, I type in set rhost, and then I set the value of rhosts. So I set that to 10.0.0.6, for example. I hit enter, and now if I hit run, you can see the exploit is going to run. And of course, I've not selected any valid target here. So it's going to tell me that the host was unreachable, which is expected, and the auxiliary module execution completed, and we really did not get any results. So again, setting options is fairly simple, and this will become more apparent when we move on to the next video, when we'll actually be taking a look at creating our payload with MSF Venom, and I'll be taking you through the exploitation of the Windows with Windows Server 2008 box, which is Metasploitable 3, and this will all become much clearer. So when you want to exit, you can type in back, and you can then hit exit, and that'll take you out of the framework, and you should be back into your normal terminal. So that's going to be it for this video, and I'll be seeing you in the next video. Hello everyone, in this video we're going to be taking a look at generating payloads with MSF Venom. Now, given that we are delving into the exploitation phase, it is very important to understand and to know how to generate payloads. Now, in the context of exploitation, payloads are essentially the piece of code that is executed on the target after successful exploitation, right? So a payload can do anything on the target. It can execute a command, it can delete files, it can download additional files onto the system. In this case, we're going to be taking a look at generating a Meterpreter payload. Now, Meterpreter essentially gives us remote access to the target system and will allow us to execute commands remotely on the target system. Now, I'm not going to get into the Meterpreter right now because we're talking about generating the Meterpreter payload. In the next video, we'll talk about encoding it so that we can bypass any antivirus when we're executing the particular payload on the target, which is very important, especially when dealing with Windows systems. So the tool we're going to be utilizing is a tool called MSF Venom. Now, MSF Venom goes hand in hand with Metasploit. And if I just open up a terminal here and I say MSF Venom and I hit enter, you can see it gives us a ton of options. But if we take a look at the information given to us, you can see that it tells us this is a Metasploit standalone payload generator. So it's used to generate payloads that you can then use with the Metasploit console, and I'll be getting into that very shortly. All right, so this is also a replacement for MSF payload and MSF encode, which is important. So let me just give you a brief history lesson into payload generation, especially with Metasploit. So before we had MSF Venom, we had two tools, MSF payload and MSF encode, which by their names you can pretty much tell what they did. MSF payload was used to generate payloads, and MSF encode was used to encode payloads to bypass antiviruses in general. And these two tools were combined into one tool, which is what we have now, MSF Venom. Now, as I said, MSF Venom allows you to generate payloads, and when we talk about payloads, there are two key elements that come into play. Number one is the type of connection you're going to be establishing in terms of the protocol. So you can see that we can generate reverse TCP connections, and we can also generate reverse HTTP connections. So we can specify the protocol to use, and then we're also going to take a look at the platform that the various platforms that are available. And the great thing about MSF Venom is you can generate payloads for various platforms. So you can generate Windows payloads right over here. You can generate Linux or Unix payloads. You can generate BSD payloads, so on and so forth, or macOS payloads. And then where it gets even more interesting is where you can actually start generating web payloads. So what I'm going to do is I'm just going to open up my browser here, and if I open up google.com and we search for MSF Venom, and we search for cheat sheet, right? And I'll just click on the first link right over here. So we have some very helpful cheat sheets that will actually list out to you all the various payloads that you can generate and the commands that you can use to run them. And these cheat sheets are really helpful because sometimes you might want to check up on various payloads that are targeted towards particular platforms. So again, if we just take a look at the examples under binaries, you can see that we can generate Linux reverse shells or the Linux Meterpreter reverse shell payload. We can also generate a bind shell, which is different to a reverse shell. With the reverse shell, the connection is actually incoming to you, or you are going to listen for the connection from the target instead of making a connection to the target where firewalls can then block the connection. So a reverse shell is usually preferred. You then have the Windows Meterpreter reverse TCP shell, which is right over here. You then have the Windows reverse TCP shell, which does not use the Meterpreter. We're not going to be using that. We also have the Windows encoded Meterpreter Windows reverse shell, which we'll be taking a look at in the next video. You then have macOS. You have the various macOS reverse shells right over here. And then you have the web payload. So if I'm running Apache and I'm running PHP on a backend on a server, I can then generate a PHP payload, which can then be executed and can then give us a reverse shell. We have ASP Meterpreter reverse TCP payloads, which are used for Microsoft Windows servers or Microsoft IIS servers. And the format, as you can see, is ASP. You also have your JSP Java Meterpreter reverse TCP payloads, so on and so forth. You also have your various scripting payloads based on Python, Bash, and Perl. So this MSF Venom is really, really robust. Now let's get exactly to what we're going to be doing. So we are going to be generating the Windows Meterpreter reverse TCP shell, and the two important elements that we need to specify are going to be your lhost and lport. And if you watched the earlier video, you remember that these two are also featured within the Metasploit fundamentals video. In this case, the lhost is the listening IP address, and that is going to be our IP address or the attacker's IP address. And this is the connection to which you want your reverse shell to connect to, so you can start executing commands. And your lport is the port that you want the target to connect to on your local machine. So you can see the command is fairly simple to run. We specify the format as exe, and we specify the file name. So we're going to generate our first Windows Meterpreter reverse TCP shell. And doing it is extremely simple. All we need to do is open up our terminal, and we'll say MSF Venom, and I'll just clear my terminal. So MSF Venom. And then we specify our lhost options, which is going to be my Kali Linux IP address. So I'll open up a new terminal, and I'll just list out my IP address. like so, and you can see it's 10.0.0.5. So we'll enter that right now. So 10.0.0.5. And then we want to enter in the L port, right? The L port is going to be the port that we want to listen on. By default, this is set to 4444. You can set it to a port that is clandestine if you want. In our case, we'll just leave it as is, and then we specify the format as exe, and we can then output this into a exe file. So we specify the file name. So I can just call this. We'll just call this payload.exe and hit enter. Right now, this payload is extremely effective. However, one problem that you'll come across when dealing with Windows and Windows exploitation is the fact that you'll come across antivirus software, which again are going to detect payloads that are not encoded or obfuscated in any sense. So again, we'll just give this a few seconds to generate the payload. It shouldn't take too much time at all. And once it's generated, we can then use this payload to gain remote access to a system. So we can either download this payload onto the target system through social engineering. We can do it through a web server, so on and so forth. We can also take a look at binding it to another exe so that, again, you can use it in a form of a spear phishing social engineering attack. In this case, you can see it's generated. It tells us no platform was selected and no architecture was selected. You can also specify the architecture by going into the Windows option right over here. So I can generate a 64-bit payload. So I can say x64 and I can hit enter. That's going to generate a 64-bit payload, which is very important. So what I'll do is I'll just let that generate. This is the 32-bit payload, and it gives you information regarding the payload. The payload size is 341 bytes, and the final size of the exe file is 73802 bytes. So again, we'll just wait for the 64-bit payload to generate, and again, it's of course it's generated two of them. So what I'll do is I'll just remove the payload.exe right over here and generate the 32-bit one more time. And in the next video, we'll talk about encoding the payload, and we'll also preserve the original version so that when we're testing it out, I can actually show you that the antivirus detects it. And again, we'll take a look at the differences between the encoded payload and the non-encoded payload. So I'm just going to wait for this to complete generating, after which we'll move on to the next video. There we are. This is the 32-bit payload, and we have it ready, and we can now move on to the next video. Hello everyone, welcome back. In this video, we're going to be talking about encoding payloads with MSF Venom. Now, again, just to go over the importance of encoding and where we're doing it, encoding essentially helps us bypass antivirus detection. Now, encoding is usually not a very reliable way of bypassing antiviruses, primarily because antiviruses on Windows are going to be signature based, and most of these signatures already have been captured. So it's going to depend on the type of encoder that you use and the various encoding frameworks that you utilize. And then, of course, there's the obvious element of crypting. Now, in this video, we're going to be focusing on the Shikata Ganai encoder, which is one of the most one of the greatest encoders that you can find actually with MSF Venom, one of the best working encoders. And of course, if we take a look at the cheat sheet that we had visited earlier, you can see that we actually have the encoded Meterpreter Windows reverse shell right over here that utilizes Shikata Ganai. However, this example does not include things like bad characters, which I'll explain in a few seconds. Now, again, generating it is extremely simple. You go about just specifying MSF Venom, specify the payload, and then you can also specify the architecture. And typically, when generating an encoded payload, it is recommended that you use a 64-bit payload instead of 32-bit. But again, 32-bit just works fine as well. So again, you specify the payload and then use the encoder option and specify Shikata Ganai, and you specify the iterations or the amount of times you want to encode the payload. The more, the better. So what we'll do is we'll go into our terminal, and if I list out MSF Venom, and I'll just open up the help menu right over here, and I'll just try and reduce the font size so that I can display things much clearer. I'm looking for the encoder option, which is right over here. So the encoder option is denoted by using the minus or -e. And then we're also going to be taking a look at the bad characters, which we can use the default ones by default, of course, which are going to be X00, XFF. And yeah, that's pretty much it. So the first thing we want to do is let's try and list out the various encoders that we have, right? So MSF Venom, and I can then list out encoders, right, and hit enter, and that's going to take a few seconds, and then you can go through all the various encoders that you have based on the use case scenario, and of course they're going to be sorted out in terms of their success rate and their functionality. So again, we'll just wait for this to load up, and then we can specify or use the Shikata Ganai encoder. So there we are. It lists out all the various encoders available. And the important thing you want to take a look at is, of course, the platform. So this is CMD. You also have x64, x86 or 32-bit. And then, of course, you have your rank, which sorts it out from low to excellent. And of course, low means this is not a very good encoder. Excellent means this is an excellent encoder. And in our case, we're looking for Shikata Ganai. All right, so Shikata Ganai is right over here. And Shikata Ganai is a polymorphic XOR additive feedback encoder. And to use it, we just need to copy the name right over here. So I'm just going to do that right now. And we can go about generating our payload. So again, generating it is very, very simple. And by the way, we can specify the payload architecture beforehand. And again, if I say MSF Venom, I can say MSF Venom, and I can then specify the architecture. If it's x86, I can say x86 or x64, so on and so forth. In my case, I'm just going to leave it to 32-bit. So I'll specify the payload, and the payload is going to be Windows. It's going to be reverse TCP. We're going to set the lhost. We'll say lhost is going to be equal to, I'll just open up a terminal just to confirm that the options are correct. And we'll say it is 10.0.0.5, right? So we say 10.0.0.5, and we say lport is going to be, we'll also set this to 4444 just to keep things standardized. And then we need to specify our encoder, right? But what we can do beforehand is we can just specify our format, which is going to be XEXE. And then our encoder we'll specify by using the E option, and then I'm going to paste in my encoder, which is Shikata Ganai. We then need to specify the iterations, so I can specify the iterations by using the -I option, and I can specify 5 iterations, and that represents the number of times the payload is going to be encoded. And then I can specify the bad characters, right? So I can specify bad characters here. So if I open up my terminal and I say MSF Venom, and I'll just use the default bad characters that we want to get rid from the encoded payload. So right over here, we'll just copy these bad characters. These are the default bad characters, and we'll just paste this in here. And we can then output this into the file name that we want. So again, we're just going to say encoded. We'll say encoded.exe, and I'm going to hit enter. And mind you, this is encoding using MSF Venom. We also have frameworks like Veil Evasion, which are much more powerful. But in this case, let's just use the default Shikata Ganai encoder with MSF Venom. So we'll give that a few seconds to generate the encoded payload. There we are. And again, it's going to use the default 32-bit architecture. It's going to say found one compatible encoder attempting to encode the payload with 5 iterations, and it gives us the final size. There we are. And if we list out the files that we now have the payload.exe and the encoded payload right over here. So what I'm going to do is I'm just going to create a directory, and I'll just say MSF Venom payloads. And I'll just create that directory, and I'm going to move all exe files, all the files that we've generated, to MSF Venom payloads. There we are. And when we now use other frameworks, we'll sort them out that way so that we can avoid any potential confusion. That being said, that's going to be it for this video. In the next video, we'll start testing out the various payloads that we've generated, and we'll take a look at generating or encoding the payloads with frameworks like Veil Evasion. So I'll be seeing you in the next video. Hello everyone, in this video we're going to be taking a look at testing the various payloads that we had generated. The target systems we're going to be using are going to be Windows 7 and Windows 10. And yeah, without any further ado, let's get started. So before we actually get started, I just want to explain a few things regarding our attack vector. Now, this is not really a complicated or real attack in, if I were to use the common terms to explain it. Primarily because we're in the early stages of exploitation, we want to test our payloads to see if they'll actually work. Now, when we move on to using frameworks like Veil Evasion, which are great, which can actually be used to engineer or to create more sophisticated social engineering attacks, where we can trick users into executing the payloads, or we can bind the payload to a legitimate executable like a setup file for a popular program like a browser or like Google Chrome. We can use multiple techniques, social engineering techniques, to actually get users to actually click on the executables and the payloads that we've created, and therefore get a reverse connection. And as I said, we'll be taking a look at more advanced attacks as we move along, where we don't need to make physical contact with the target. But in this video, we're going to be doing it manually. And the reason we're doing this is to actually show you the difference between the encoded payload and the unencoded payload, and how the various antivirus solutions respond. So without further ado, let's get started. Now I'm going to head over into my encoded payload directory. So MSF Venom payloads, and if I list out the payloads, we have encoded and the payload.ext right over here. So we'll start off with the Windows 7 virtual machine. The first thing we need to do is we need to get these payloads onto the target system. One way we can do that is by setting up a web server and then navigating to that web server, downloading the files manually on the target and executing them. Right? So we can do that really simply by either setting up Apache, or we can use the simple Python module, a simple HTTP server, to set up a very quick and robust web server. So to do that, we need to say Python M, and this requires root privileges. So we say sudo Python M, and we say simple HTTP server. And we can then use tab auto completion, and we specify the port we want to listen to. So we'll say port 80, and it's going to, as you can see, it's going to serve all the files within this directory on port 80 on the Kali Linux virtual machine. And in this case, if I open up a new tab and I just list out my IP, you can see it's 10.0.0.5. All right. Now, before we actually get into executing the payloads on the target, we need to set up our reverse listener, because remember, these payloads are reverse shells, which means they're going to connect back to us. And in order for them to connect back to us, we need to be listening to them. We need to be listening for them. And the way we do this is by using the exploit handler with the Metasploit console. So I'm going to open up the Metasploit console here. We'll give that a few seconds. And once we specify the exploit handler, we then need to specify the payload that we use to generate the various the payloads that we actually generated. So we just need to specify the options that we used when we were creating the payload, and specify the port and the IP that we had specified. So we say use exploit. This is use. Like so. And then we specify the payload which we had used during the creation process, which was set. So we say set payload. And we hit enter. You can see the payload has been set. So if I say show options, you can see that the only options we need to set are the options we had set when creating the payload. So we need to just specify, in this case, the lhost, which is the Kali Linux IP. So again, we say set. Hit enter, and the L port is set by default to 4444, which we had already set when we were creating the payload. So now that we have that running, or now that we have that set, we can now run this and set up the listener. So you can see it's set, it started the reverse TCP handler on the Kali Linux IP and on the port 4444. So it's now currently listening for connections. So now we need to move on to the next stage, where we try and download the payloads onto the Windows 7 target and execute them, and let's see if we can get a Meterpreter session back. All right, so I'm just going to open up the Windows 7 VM, which is right over here. And again, we're going to access the web server that we created with the simple HTTP server with Python. and that is going to be serving the files from the Kali Linux IP address. So I'll just clear the, I'll just get rid of that, and that is under 10.0.0.5. I hit enter, you can see the web server is set up successfully, and we can now start downloading the payloads. Now by default, I've disabled Windows Defender. So if I click on Windows Defender, right, sorry, that is incorrect. Let me just search for Defender. That is Windows Defender, there we are. And we take a look at tools and options, and real-time protection is currently enabled, right? So that is currently enabled. So I'll click on encoded, or I'll click on the payload first. This is the unencoded payload. So I'll click on that and I'll save the file, and there we are. If I open up my downloads folder, the payload is still there. So the antivirus hasn't done much yet. So I'll run this as administrator, hit enter, and the payload is now running. So how do we know if we've actually got a reverse shell or a reverse Meterpreter session? If I go back into Kali, you can see it sends the stage to the target. The target has an IP of 10.0.0.12 or 12, and we get a Meterpreter session that is opened, and we now have a Meterpreter session, and that is denoted by this Meterpreter line right over here. So the Meterpreter session essentially allows us to execute commands on the system, and it gives us remote access. So an example of this is if I say sysinfo, this will list out the information on about the target. So in this case, you can see it's Windows 7 and gives us information regarding the service pack, the architecture, the work group it belongs to, and the Meterpreter session. In this case, is a 32-bit Meterpreter session. Now you can also get more commands from your Meterpreter by clicking on the help option right over here. So if I just click on help, just open that up right now. So there we are. We can use the help option, and the help option gives you all the various commands that you can run. Meterpreter is an extremely powerful tool. You're able to essentially do anything, and I'll just take you through some of the important ones. So the first thing we want to take a look at are the core commands. So the core commands allow us to deal with the Meterpreter session. So we can background the session and have it running in the background while we try and exploit other machines. We can also take a look at processes in the background that are currently running on the target. We can migrate to these processes, so on and so forth. We'll take a look at the other ones. For the file system commands, we can download files or a directory onto the system. We can also print the working directory, all the various Unix commands that you're familiar with running. We can also upload files. We can search for files, so on and so forth. We can also get a shell on the system, which will give us a command prompt, remote command prompt. We also have networking commands. We can take a look at the IP configuration. We can take a look at the route configuration right over here. We can also take a look at the standard API system commands, which allow us to perform some post-exploitation techniques like clearing the event log on Windows. We can drop a token for impersonation. We can execute a command. We can get privileges. So this will essentially try and escalate our privileges automatically. We can get the user ID, so on and so forth. We can reboot the system, so on and so forth. We can also then perform some user interface commands like get the desktop, and that'll get the current Meterpreter desktop. We can key event, send key events. We can send keystrokes. We can dump the keystroke buffer. We can start capturing keystrokes. And yeah, so there's tons of commands that we can actually do. And then of course, when we talk about password commands, we can perform a hash dump, which will dump the contents of the SAM database. So if I perform hash dump, for example, so if I say hash dump, hit enter, it gives us the various hashes for all the users on the system. If I say get system, which will try and elevate my privileges, you can see it got the system, and we were successfully able to elevate our privileges using the named pipe impersonation. If I type in get user ID, and I hit enter, we now have NT authority access or administrative access on the system. I can then hit shell, and that'll give me a command prompt, which you should be familiar with. There we are. And I can then run commands like so. I can then terminate this and go back into my Meterpreter session. As I said, if I want to background my session, I can say background, and that is going to background the session. The session is still running, so I can then, perform exploits. I can then also set up other listeners and get other reverse shells, basically do anything with Metasploit while that session is running in the background. If I type in sessions, you can see the session is under active sessions, is currently running, and that means I can switch to it at any time. To do that, I say sessions and provide the session ID. In this case, it's going to be 1, and I hit enter, and you can see I'm back. I say get user ID, and that lists out NT Authority system. So again, we can see that that worked successfully. And in terms of Windows 7 Service Pack 1, the antivirus really didn't detect anything, which is a good sign. So we can take a look at the encoded payload, and then we'll take a look at whether we can do this on Windows 10 as well. All right, so what I will do is I will say exit, and that is going to shut down the Meterpreter session, and we'll just set up a listener again. And what we're going to do now is let's try and run the encoded payload, which again will not make much of a difference. So I'll just delete the payload that is unencoded, and we'll just download the encoded payload right over here, save file. That's going to save the encoded one, and we'll just run this as administrator. And if we go back, you can see we get a Meterpreter session. And again, there isn't much of a difference, primarily because we're dealing with an older version of Windows. And again, I can say get system, and that should get, in this case, you can see it's telling us that access is denied. And that's primarily, I think, because we have obfuscated the payload. So again, if I say get user ID, because we run this as the administrator, we still are logged in as the IE7 user or the Internet Explorer user. So now you can see that automatic privilege escalation has failed. We now need to perform manual privilege escalation, which is what we're going to be taking a look at in the privilege escalation section. All right, so we still are able to get a Meterpreter session on Windows 7. So what I'm going to do now is I'm just going to start up the Windows 10 virtual machine, and I will just exit from this session, and we can then test it on the Windows 10 VM. All right, so I've set up the Windows VM, and it's currently running. So the first thing we want to do is let us set up the listener on Kali here, and we can now head over to the Windows VM. And we're going to start off by disabling the antivirus firstly, and the antivirus we're going to be using by default is Windows Defender. And again, the purpose of this video is to just explain to you the differences, between the encoded and unencoded payload. And then of course, we'll be talking about more advanced encoders like veil evasion. So I'll just open up my browser, and you can actually see on Windows Defender, I currently have that disabled. If I click on Virus and Threat Protection and click on Manage Settings, real-time detection or protection is also disabled. Essentially, the antivirus is disabled, and we're going to be using the encoded payload because the payload or the unencoded payload is going to get detected really easily, and the encoded payload will work by default when Windows Defender is disabled. So I'll just click on the encoded payload and hit save. And Windows 10 by default should have various security features enabled to prevent me from executing this. So if I double click to run it, it should actually tell me that Windows is protected my PC, but I can execute it anyway. If I click on Kali, we still have that listening here. So I'll just hit run one more time, and we get a Meterpreter session again. And this time it successfully looks like Windows Defender had the scheduler enabled, which kept it running in the background. This is one of the problems with Windows. So there we are. It looks like we have access. And if I type in sysinfo, you can see we currently have access. We have Windows 10 and the build number, and the architecture is 64-bit. So given that we know the architecture, we can actually try and migrate the Meterpreter session because it's currently a 32-bit Meterpreter session. We can migrate it to a 64-bit Meterpreter session, which is much more reliable because the architecture that's running on the system or the actual system is 64-bit. So to do this, we need to analyze the processes that are running on the target, and of course, I can list that out by typing in PS. And the process that we're looking for, because all processes have the 64-bit architecture, the process we're looking for by default is the Explorer.exe. This is the most stable process that you can migrate to when dealing with Windows. So I can look for it right over here. I can look for Explorer.exe, and that has a process ID of 5308. So if we want to migrate to this process, all we need to type in is migrate and the process ID, which is listed right over here on the first column. So I can type in migrate, and I say 5308, and I hit enter, and that should migrate to that 64-bit process, and it tells us migration completed successfully. If I type in sysinfo now, you can now see we have a 64-bit meterpreter session, and again we can then try and run all the various other commands. So if I say hash dump, you can see that that is going to fail because we're dealing with a more advanced, newer operating system, in this case Windows 10. However, as I've showed you, we can still get a meterpreter session with with Windows Defender disabled. However, again, Shikata Ganai is now outdated. However, it will work on older versions of Windows like Windows XP, Windows Vista, Windows 7, Windows Server 2008. For the latest versions of Windows, you want to start using other encoders like the Veil Evasion framework, so on and so forth, which we'll be covering. So that's pretty much all I wanted to cover in this video. This was just a very basic foray into testing the various payloads that we created and showing you how to establish a remote connection to your target, how to, we've taken a look at some of the basic meterpreter commands. We'll be taking a look at a lot more as we move along. But that's going to be it for this video, and I'll be seeing you in the next video. Hello everyone, in this video we're going to be taking a look at the Eternal Blue exploit, specifically targeting Windows 7 and any older operating system. So this will not work on Windows 10 and later. So again, I'll just take you through one of the actual disclosures here, or really just a primer that gives you more information regarding this particular exploit if you're not familiar with it already. It was famously used by the WannaCry, or used in the WannaCry attack, and it is an exploit developed by the NSA. So Eternal Blue is an exploit that allows cyber threat actors to remotely execute arbitrary code and gain access to a network by sending specially crafted packets. It exploits a software vulnerability in Microsoft Windows operating systems SMB, or Server Message Block version 1. So again, this is more specifically going to affect only Windows operating systems with SMB version 1. A network file sharing protocol that allows access to files on a remote server, and by default Windows will typically have SMB enabled, as it's again used for sharing files and peripherals like network devices like printers, network attached storage, etc. So this exploit potentially allows cyber threat access to compromise the entire network and all devices connected to it. Due to Eternal Blue's ability to compromise network, if one device is infected by the malware via Eternal Blue, every device connected to the network is at risk. Now, as I said, we're going to be exploiting the Eternal Blue exploit, and we are going to be targeting the Windows 7 virtual machine. So I already have that up and running, and again, we'll just open up MSF console. Metasploit already has a module built in for this particular exploit that allows us to again gain access. This exploit will give us a meterpreter reverse TCP session, which means we can execute commands on the target. And again, if you compare it to the manual types of attacks where we had to manually generate payloads, in this case we don't have to make contact with the operating system. It can be done remotely. The only thing you need is the target's IP address. So I will search for Eternal Blue, and we're not talking about the double pulsar vulnerability. We are primarily talking about the Windows. This is exploit Windows SMB MS 17010 PSExec. So again, this will allow SMB remote code execution. So we're going to select that module, and we can then use, we say use, and we hit enter, and it's going to specify the default payload as Windows Meterpreter Reverse TCP. If your version of Windows or the target version of Windows is running a 64-bit, ensure that you set the payload to set payload, and you specify Windows x64, and again Meterpreter Reverse TCP. In my case, the target is a 32-bit version of Windows 7. So again, I can just hit show options, and the options that we can set are listed above here. So again, we need to set the rhost to the target, and pretty much everything else can be left by default. So what we can do is we can say set rhosts, and we're going to set that to 10.0.0.12. That is the IP address of the Windows 7 virtual machine. So I'm going to hit enter, and that's pretty much all we need to do. The SMB port by default is going to be 445, and that is how it is configured on Windows systems. All we need to do now is hit run, and it's going to start, and there we are. It's going to send the stage for us, and we get a meterpreter session. And again, I can confirm that by typing in sysinfo and I can hit enter, and there we are. We can see it's Windows 7 Service Pack 1. It's a 32-bit system, and we have a 32-bit version of Meterpreter running. Again, we can then run additional Meterpreter commands like get system. I hit enter and we get the system. If I get use ID now, you can see we have NT authority and we have administrative access. So just through one exploit, I was able to get administrative access using Metasploit without having to access or having physical access to the target machine, without performing social engineering. The only thing I require is the target IP address, and of course the parameters have to be that it is running Windows 7 or older. Right now, we're going to be talking about various other types of attacks, and in the next module, we'll be talking about encoding using particular frameworks like Veil Evasion, where things will become much more interesting. So I just thought I would take you through the Eternal Blue exploit. Again, you can try it out with your own virtual machines. Extremely powerful and can lead to the compromise, as mentioned within the primer here, of an entire network. And again, this was used during the WannaCry ransomware attack, and it was usually targeting various companies and hospitals that still had older versions of Windows 7 Enterprise running, which again were vulnerable to this particular exploit, and they were able to gain access extremely simply, or really easily. And as you can see, I was able to get administrative privileges, which means I practically own the system at this point. That being said, that's going to be it for this video, and I'll be seeing you in the next video. Hello everyone, in this video we're going to be taking a look at some of the essentials of Meterpreter. Now in this module we're going to be focusing on post-exploitation and privilege escalation, and one of the tools that is extremely important to know when performing privilege escalation or post-exploitation, and generally speaking maintaining access on the target system, is Meterpreter. Now the great thing about the Metasploit console and Meterpreter in particular is the fact that it is very well documented and you have very useful help menus. So for example, if I just list out the help menu by using the question mark symbol and I hit enter, you can see all the useful commands are sorted out based on functionality in their various categories. And again, in terms of the core commands, you have them listed right over here. We'll be taking a look at some of the essential commands that will really get you up to speed with the Meterpreter. And then of course you have your basic file system commands, which allow you to navigate the system, print out information, edit a file, print your working directory, make a directory, so on and so forth. And then you have the ability to, of course, enumerate system information, and we'll talk about that shortly. So without any further ado, let's get started. Now, the way I'm going to start is I'm going to set up a scenario where we have just gained access to a system. And the first stage is to enumerate information about the system. So to find out more about the system we're dealing with. And the first command we want to run is sysinfo, right? So we type in sysinfo, and this does exactly what it says. It lists out information about the system. More importantly, it lists out important information about the system. So in this case, you can see it tells us the computer name. It lists out the operating system, so Windows 7. It lists out the build number and the service pack, which is extremely important when trying to find various vectors for privilege escalation, whether they be kernel-based exploits or service-based exploits. It gives us the architecture, which in this case is 32-bit, the system language, the domain it is a part of, the logged on users on the system, and the Meterpreter architecture right over here. The Meterpreter architecture and the type. That being said, that's how to enumerate basic system information. Now, of course, we can try and enumerate other bits of information, like first of all, getting to know what user we're currently logged in as. So if I say get user ID, when we hit enter, you can see we currently have administrative privileges, and that is denoted by the NT authority system option here. So again, that means we pretty much have administrative access. But again, this video is just explaining the basics of and the essentials of Meterpreter. So we can also get into a command prompt, or we can get a shell on the system. Now, when we talk about a shell, this is not going to be the same as a Meterpreter session, because when we're dealing with a shell, we are directly interacting with the system through the command prompt. So that means we are only going to be limited to Windows-based commands. So if I hit shell, you can see it gives me a command prompt as you would expect, and I can now execute Windows commands, which is excellent. So I can say net users, and that will list out all the users on the system. In this case, you can see we have administrator, SSHD for the SSH server, SSHD server, guest, and internet user. So again, we can then perform commands like ipconfig. We can take a look at the network route information, and we can perform a plethora of other Windows-based commands. Now, when we're done working within the command prompt and we want to return back into the Meterpreter session, all we need to do is type in exit, and that'll take us back into the Meterpreter session. All right. So now that we've taken a look at some of the basic information enumeration commands, now let's take a look at navigating the system and trying to understand what's running on the system. So let's start off with file system commands. So file system commands are going to be pretty much the same to Linux, and of course it'll have some commands that have been appropriated from Windows. So for example, if I want to change my directory, I can specify the directory I want to navigate to. In this case, we're running Windows, so I can navigate to the root directory of the C drive, and if I display the files, I can use dir or ls, and I can hit enter, and there we are. That lists out all the files and directories within the C drive. And then of course I can change directory into any of these. So I can say users and cd, we can list the files in here. We can say cd, I want to get into the IE user directory, so IE user. I can then list the files in here. I can then go over to the desktop and I can hit enter, and there we are. Now, some important desktop or file system commands are going to be the ability to upload and download files to the target, to and from the target. So if we find a valuable file on the system, we might want to save it onto our system, or we might want to download it because we might want to use it later, right? So to do that, all we need to do is the first thing I'll do is I'll just create a file here. We'll try and upload a file to the system. So I'll just list out, we're currently in the Kali root directory. So I'll just say touch, or I can just echo the data directly. So I can say echo, this is some test data, and I can then output this into text.txt and hit enter. So text.txt, and you can see that that file contains this data. So let's try and upload this text.txt onto the desktop, and we can display that by printing in the working directory. So we're currently on the desktop of the IE user. So let's try and upload the text.txt file here. So to do this, all we need to do is type in upload, and we can then specify the directory to the file that we want to upload. In this case, we're currently working in the home directory. So I'll say text.txt and hit enter. And you can see it's going to tell me it's uploading it. It gives us the progress, and it tells us that it's uploaded. So if we list the directory now on the desktop, you can see we have text.txt. So if I open up my Windows desktop, you can see the text.txt file has been added. And if I open that up in a notepad, it tells me this is some test data. So that was successful. Now, let us try and do something else. I'll create a new file here, and I'll say, we'll just create we'll say a text document. We'll say, we'll just say passwords, right? Let's say someone has saved their passwords, and what I'll do is I'll put this within the documents directory. There we are, and we'll just enter in here, and we'll say AWS passwords is equal to pass 2020 AWS, just something basic to set up a basic scenario here. So again, let's say we are navigating through the system using Meterpreter. So again, we currently on the desktop. Let's go a step back here. And we want to go into the documents directory. So documents like so. And you can see that we have a passwords.txt file, which is interesting. So let's say we want to download that to the Kali system. All I need to do is type in download passwords.txt, passwords.txt, hit enter, and it's going to download the file. And if we take a look at the home directory for the Kali user, you can now see we have the passwords.txt file in here. So I can hit enter, and it gives us the data that we added right over here. So I'll just delete that file now because we do not need it, and I'll also remove text.txt from our home directory. And if I want to do the same here, I can say remove passwords.txt, and that removes it. If I go back and I say I want to go into my desktop now, so cd desktop, and I say remove, and of course I say text.txt, and that is gone. Right, so those are the basic file system commands, and of course we can now move on to some of the more interesting commands which are going to deal with processes. So processes are an integral part of post-exploitation and privilege escalation, primarily because it gives you a very clear picture of what's running on the system, and it also gives you an idea of what processes you might want to migrate to. And we've already taken a look at migration in the previous sections. So again, to list out the processes, we simply type in PS, right? And PS will list out all the processes, and it sorts it out into your process ID, the name of the process, the architecture, which is very important when you're migrating into a 64-bit, if you're migrating into a 64-bit session or process that is currently using 64-bit. And then of course you have the session, the user, so in this case NT authority, and various other users like IE user right over here. So I can also migrate, for example, into the explorer.exe process that is currently using the IE Win7 user or the IE user, which is currently running. It is currently a 32-bit session right over here. So to migrate into a session, the important information that you need is going to be the process ID, right? So the process ID is what we will use. So in the case of Explorer, you can see the process ID is 1496. Now, if we are looking for a particular process on the target, we can use a tool called pgrep, which is process grep, and I can enter the name. So if I'm looking for PowerShell and I hit enter, it will give us the process ID for PowerShell.exe, and you can actually see, we can confirm that it is 3496. So let's say we're looking for pgrep Explorer, and that is 1496. So I can then say migrate 1496, right? And I hit enter, and that's going to migrate into that particular process. There we are, migration completed successfully. So get UID, we hit enter. You can now see we're not logged in as the administrator, and we're currently using the IE user, which does not have administrative privileges. All right, so now we're in a perfect place to start talking about other commands like get system and hash dump, right? So the get system command allows us to escalate our privileges. So if I say get system and I hit enter, you can see that it's going to tell me the privilege escalation failed, and this is using these various techniques right over here. Now, as we'll move along to the independent videos where I'll be covering Windows 7 privilege escalation, we'll talk about how to get privileges, how to escalate our privileges using kernel exploits and various other useful tools with the Metasploit console. All right, we also have the ability to dump hashes, and that is done using hash dump. If I hit enter, you can see we'll not be able to do that because we do not have administrative privileges. So if I list out the processes again, and I currently can only see, because I do not have the various privileges, the various administrative privileges, you can see that I cannot view important information like the user information in regards to the NT authority. So again, what I would need to do is I can try and migrate into any of these services here. So I can say, let me try and migrate into svchost.exe. So I can say migrate 3220, hit enter, and that does not work because we have insufficient privileges. So again, we need to escalate our privileges manually. So we'll be taking a look at that as we move along into the next videos, but I just wanted to actually demonstrate this to you right now. So what I'm going to do now is I'm just going to terminate this session. Now if I want to terminate a session, I can hit exit, right? And I can hit exit, and then since we're using Eternal Blue, I'll just hit run, and that'll give me another Meterpreter session with NT authority privileges. So get UID, hit enter, and there we are. Right, so let's move along to some of the important commands. Number one is the ability to background our session. So if we want to move this Meterpreter session into the background and maybe run some other Metasploit modules, we can just type in background, and that will send this into the background, and we can view our sessions or our background sessions by typing in sessions, and you can see it gives us our sessions right over here, the IP address that we're connecting to, and the information regarding the system like the computer name and the user we're logged in as. And if we want to go back into that session, we need to type in sessions and the session ID. So we could have up to 100 sessions or even more. So the ID is very important. So I hit sessions 3 and we're back into the system with the Meterpreter session. Right. So now that we've taken a look at the background and sessions, let's take a look at some more important ones that we can perform, which are really, really fun to run. Of course, we can take a look at hash dump, which will simply just dump the hashes from the system. Now, this will not work on newer versions of Windows because the SAM database is protected. But again, we can then use these hashes for password cracking, which we'll talk about in its own module. So let's take a look at some important commands that we can run. Of course, we have the ability to run commands based on the user interface. Now, of course, we have UICTL, which is very, very important. So we can use UICTL to enable or disable the keyboard or the mouse, which again can be very useful. Now, I'm running a virtual machine, which pretty much means that the way I interact with the user interface is through a different layer as opposed to the USB or the universal service bus layer. So it'll really not work if I try and demonstrate it to you. But in order to do that, all I need to type in is UICTL. I can say enable. I can say disable keyboard. So disable keyboard. Now hit enter, and that's going to disable the keyboard. Now again, it's very important that you know that this is only going to work on systems that are using USB. When I'm running it in a virtual machine, it really will not work because again, I'm interacting with it very differently. So I can then enable it again. And again, I can do the same for the mouse, right? So enable keyboard, and I can do the same for the mouse. So I can say disable mouse. And again, disable, and I can then say enable mouse, right? So it's very simple and very, very useful. So that is a UICTL. And of course, we can now talk about some of the other important commands, which is related to the user interface. And that is the ability to, I'll just open up the help menu because I want to actually show them to you, is the ability to actually, what we can do is we can use the inbuilt keylogger. So we can actually, this is the one, right? The key scan. We can start capturing keystrokes, and this will act like a keylogger. So any commands that are being typed in on the target will be captured. We can also do the same for the mouse. We can also take a screenshot of the desktop. So what we can do is let's try and take a screenshot of the desktop first. So screenshot, hit enter. It's going to save it in the home Kali directory. So if you open up a new terminal, or we just open up the home directory, you can see we've taken a screenshot right over here. So what we can do now is let us try and run the what we can do is we can try and run the key scan start and stop commands, or we can dump the entire keystroke buffer. So we can say key scan dump. So key scan dump, and of course that will not work because we need to enable the key scan. So we say key scan start, and then that will start capturing it. So key scan start, hit enter. It's going to start the keystroke sniffer. So if we go into the Windows box here and we just type in, we can say cmd.exe, open that up. We can then say we're looking for net users, and we can say ipconfig, the basic commands you'd run, and we then close that out. So we then say go back into our Kali box, and we say key scan stop, hit enter, and we say key scan dump, hit enter, and it's going to give us an error, and that is again primarily because of the fact that we're dealing with a virtual machine, and we do not have the ability to we're not interacting with a USB keyboards and mice. So again, we can use any of the user interface commands right over here, but of course in this case it really doesn't make a difference because, it will really not make any impact because again we're running it in a VM. So those are the important commands that you can run here. Now of course I want to take you through some other important ones, and one that you'll be forced to run quite a bit, and that is the ability to execute EXEs. So for example, what I can do is, let's see if I can find winrar.exe here. So we'll look for winrar.exe, and that probably is within the program files, but we actually should see it right over here somewhere. So This is under the, what directory are we under? We are under Windows System 32, right? So if we go back and we say, yeah, we have, for example, notepad.exe. If we want to execute an exe file, all we need to do is type in execute F, and we say notepad.exe, hit enter, and that's going to create notepad.exe. And again, what we can do now is, if we try and take a screenshot of the desktop, we hit enter. Let's see if we're able to actually see whether Notepad has been opened. It looks like it executed, but it did not display the, but you can see the process has been executed right over here. And that's primarily because it's executing it as NT authority as opposed to the IE user. So again, that is a process that is created under NT authority. And of course, if we were running or we were currently using the IE user, then it would actually be displayed on our desktop. So again, that is a very simple way of executing executables and any other executable file on Windows, whether it be a batch file, so on and so forth. And then, of course, you have the ability to suspend or kill processes. So again, I can kill the notepad.exe process. So 29, that is 2920, hit enter, that's going to kill it. PS, and you can see the notepad.exe is actually closed now. So those are essentially all the fundamental and essential interpreter commands that you will need when performing exploitation, post-exploitation, and privilege escalation. Of course, as we move along, I'll be taking you through some of the other commands that you can run, but we're going to be focusing primarily on modules. And then when we talk about manual exploitation, we'll talk about file transfers and other techniques like that. So that's going to be it for this video, and I'll be seeing you in the next video. Hello everyone, in this video we're going to be taking a look at persistence with Metasploit. Now, when we talk about exploitation, more specifically post-exploitation, one of the most important things you can do as a penetration tester is set up persistence so that you can maintain access on your target. Now, let me just give you a simple example. Let's say we exploit the Eternal Blue vulnerability and we get access to a target on a network. And again, we want to have continuous access to this target for the next 2 weeks. But we don't set up persistence. Instead, we keep using the Eternal Blue module with Metasploit to gain access. When we come back 2 weeks later, we can again we can take a simple example. Let's say that particular Windows machine or Windows computer has been patched or has been updated, and that particular machine is not vulnerable to the Eternal Blue exploit anymore. Well, how do we get access then? Well, this is where persistence comes into play. Persistence is the process of setting up, a persistent access on the system so that you constantly have access and you do not need to keep on exploiting the vulnerability to gain access. Now, this comes into play especially when talking about Meterpreter sessions. And again, to do this, we're going to be using the persistence module with Metasploit. Now, the scenario or the environment we're going to be using for this particular video is our target is going to be the Windows 7 virtual machine. And I already have a Meterpreter session running here. And the way I was able to achieve this is through the Eternal Blue vulnerability, as we've done before. So if I say sysinfo, I just want to, again, just show you that we're running Windows 7. So there we are. So the first thing we want to do is we want to background the session, right? So background. And now that is in the background, we can list these sessions, and you can see the ID is session 3, and we have that running in the background. That's excellent. So the module we are going to be using is a post-exploitation module that requires an active session on the target that you want to set up the persistence on. So we're going to search for persistence, right? So we're going to say persistence, and we search for that. And the one we're looking for is going to be this one right over here. We're looking for VSS persistence, or we can also use the persistence service, right? So these are all you can use any of these, but the one that I recommend the most is going to be the exploit Windows local persistence, and this uses the Windows persistent registry startup payload installer. So what this does is it sets up the payload within the registry, so that every time the system reboots, we will still get a session, and all we need to do is set up an exploit multi-handler or a listener, and we'll get a connection, and we'll have continuous access on the system without having to exploit any particular vulnerability. So we'll use this one right over here. We'll just copy this right now. So we say copy, and we're going to say use. I'm going to paste that in there, and we'll give that a few seconds. By default, it's telling us that no payload has been configured, defaulting to Windows Meterpreter Reverse TCP. So that is referring to the particular payload that we want to set up in regards to persistence. In this case, this is perfectly fine because our target is running Windows, and we do want a Meterpreter session, and Reverse TCP is fine. So if I say show options, and let's take a look at the options here that we can provide. This is going to be very, very important. So the options that we're going to take a look at are going to be the following. So number one, we set the delay time. So the delay in seconds for the persistent payload to keep reconnecting back. So again, after every 10 seconds, the payload is going to keep it's going to keep connecting back to us. And again, if we set up a listener, we should be able to get a session. We then provide the exe name, which should be as clandestine as possible. So you should name it preferably after one of the services on Windows, so that it's easily masked and no one can really detect it. And then, of course, we can provide the session, which we know is session 3. And that's pretty much it regarding those options. Now, in regards to the payload, we can now start setting up various options like the listening, the IP that you want the connection or the persistent module or payload to connect back to, and the port. Now, if we take a look at the advanced options, so show advanced, right? What we are going to be looking at changing is, because we can specify our own payload here. We can set that, but we can also go about setting this or setting the payload by setting payload as follows. So we can say set payload, and then we can say Windows, which is already set for us. So Meterpreter Reverse TCP. So we can, since we already have that set up, we can say show options, right? And we can change the L port, because if we take a look at our sessions here, we can see that the session that we already have running is listening on port 4444. So we cannot have two sessions listening on the same port. So we'll set L port, and we'll set that to something like 1234, and we hit enter, right? And if we list this out now, I'll just, sorry, I don't want to list that out. We're going to say show options one more time just to make sure that that is set correctly. We now need to set the exe name. So we're going to say set exe name, and we'll set that to something like svc host, right? And we hit enter, and that will be the name of the exe. And what we'll do now, we can also set up the startup type for the persistent payload. We can set up user or system. I'll just leave it as user, and we'll just hit run, right? Yeah, we need to set the session, sorry. So session, set session 3, and we're going to hit run, right? And there we are. So what's going to happen is, you can see it's going to run the persistent module against the target with session 3. So note the current user system and startup equals user. This may not log in often. So we can also set it up as system. So the persistent VBS script is written under the temp directory. And again, it's going to install it into the registry, as you can see. And it's going to install the auto run so that it runs on startup right over here. And it's going to clean up the Meterpreter RC file. All right. So now that we've set up persistence, what we can do is we can use the exploit multi-handler. So we'll say, what I'll do is I'll open up a new Metasploit console session. Of course, I can use the same one. I think we should actually do that. That'll be much easier. So I'll just say use exploit, and we'll say multi-handler, right? And we'll say set payload. We need to set the payload to Windows, Meterpreter Reverse TCP, show options, and we're going to set the L host to our IP, so 10.0.0.5, and we set the port to what we had set for the persistent module. So set L port to 1234, and we hit run. right? So it's going to set up the listener on our IP on port 1234. And because we already have the persistent payload set up, what we need to do now is we can just restart the Windows 7 VM. So I'm just going to go into Windows 7 here, and we're going to say restart. So again, just pay attention to what happens now that the Windows VM is being restarted. And I'll just keep the box right over here. So you can see it's starting up Windows. And it should give us a Meterpreter session now whenever the system restarts. And after, or if we do not, if we are not listening for it actively, the payload will keep on trying to reconnect after every 10 seconds. So again, I'll just open up Kali right over here. So you can see it's still telling us that the Meterpreter session died, which is fine. What we can do is just hit run again, because remember, it's going to try and connect after every 10 seconds. So again, we'll just let that listen, and after every 10 seconds, we should get a connection back, and we should be able to get a Meterpreter session. So again, we'll just let this wait. All right, so as you can see, after a few seconds, we get a Meterpreter session. And again, if we take a look at the Windows VM, it's just restarted now. And we get a Meterpreter session, and after every 10 seconds it's going to keep reconnecting. So again, for some reason it's closed. So we'll just try and perform some commands here. You can see it's still working. But if I exit, right, and I just run the handler one more time, you can see that after every 10 seconds, it will reconnect back, and we have set up persistence on the target. And there we are. You can see after every 10 seconds, we get a new session if we don't have one already. And again, if I just put this in the background, you can see that we have the session right over here. And of course, after running the persistence module on our earlier session, that session is going to be closed, primarily because we've restarted the system. So again, now that we have persistent access, we can say sessions 6. And if I just go back into that, and you can see that's working. Now, the cool thing with this is if I exit out of Metasploit entirely, I can start up Metasploit one more time, and I'll just show you that I do not have to run any particular exploit. All I need to do is set up the exploit multi-handler, and I should be able to get a connection back, regardless of whether the system has been restarted or anything like that. So that's one of the advantages of setting up persistence. So I'll say use exploit. We'll say exploit multi-handler like so. Set the payload to Windows Meterpreter. Sorry. We say reverse TCP, right? And sorry, that looks like an issue there. Windows Meterpreter. Yeah, there's a spelling mistake. So Meterpreter. And one more time, let me just correct that. There we are. All right, so show options, and we set the L host, and I can set this to Ethernet 0 on my IP address, and then I say set L port to 1234, and we hit run, right? And we set up the listener now, and again, after a certain period of time, or after the duration that we had set, we get a Meterpreter session, and there we are. So we don't have to even run any or even exploit any vulnerabilities, and there you go. So that's pretty much going to be it for this video, and I'll be seeing you in the next video. Hello everyone. In this video, we're going to be taking a look at elevating privileges on Windows 7. Now, I'm just going to be following along from the previous video where we had set up persistence, and I'm going to be using that exact same Meterpreter session that we have now set up, and we should have at all times. So if I list out the system information here, you can see that indeed I am logged in on the Windows 7 VM, and if I say get user ID, we are currently logged in as the IE user. However, if we go into my shell and I say net users, you can see that we have the ability to gain administrative access on the target, which is the NT authority user. And that is what we're going to be targeting. So we are targeting, or we want to get the highest privileges possible so that we pretty much have total control over the system. That being said, I'm just going to exit from this, and there we are. We're back into the Meterpreter session. When we talk about post-exploitation and privilege escalation, it's very important. The first bit of information that's very important is to understand what operating system you're running. And when I talk about the operating system, I'm referring to the version and the service pack, which are going to be extremely relevant. Now, the awesome thing about Metasploit, or the Metasploit framework, is that we have a module, a post-exploitation module, that will actually use a session on the target, that we have an active session, and will actively probe the target and get relevant information from it, like the operating system version, the service pack version, etc. And it's going to suggest various exploits that we can use to escalate our privileges. So again, with Meterpreter, we can use the standard get system option, which again will fail because again in most cases the get system option does not work on newer versions of Windows, so that will not work. And again, if we want to perform any hash dump here, you can see that is going to fail as well. So what I'm going to do now is I'm just going to background this. So I'm going to say background, right, and that is going to background it into session 1. So sessions right over here, and we have the session running. Excellent. So we are going to search for a module called Suggester, right? And there we are. It's the first option. It's the only Suggester module. As you can see, this is an exploit Suggester, and it runs this locally on the target. So it's very important that you have an active session on the target, and we're going to require the session ID. So we're going to say use, and we're going to use this module. So if I show the options now, we say show options, you can see the only option we need to set is the session ID. So if I list out my sessions, the session ID is 1. So I'm going to say set session to 1, right? And we're just going to hit run. All right. So what this is going to do is it's going to look at the information from that particular session. And as you can see, in this case, it's going to start collecting local exploits for 32-bit version of Windows. And of course, it already knows that it's running Windows 7, Service Pack 1, and the build number. So it's going to give us relevant modules that we can use to try and elevate our privileges. So what I'm going to do is I'm just going to wait for this to complete scanning, and it's then going to give us a list of modules we can use. So there we are. We can see that it's ran 34 exploit checks, and it's given us the various modules that we can use here. Now, of course, this is going to entail a certain amount of trial and error. And again, you might want to try out all of these ones, but again, you can perform research regarding the version of Windows that is running on your target and which of these modules is most likely to give you administrative privileges. In our case, let us test out the first one right over here, which again uses the bypass user access control functionality, which is quite stable and is also very, very successful. And this targets the event viewer. So I'm just going to copy that, right? I'm going to say copy, and we're going to use this module. So I'll say I'm just going to paste that in there. And by default, it's going to this module is going to give us another reverse. It's going to give us another Meterpreter session with administrative privileges. So you can see the default payload is set to Windows Meterpreter reverse TCP, which is perfectly fine. So if I say show options, it tells us that for the payload options, we set our L host and our L port. Make sure that your L port that you set is not in conflict with your listener or with your original Meterpreter session. In my case, it's not. That one is set to listen on port 1234. So again, I'll leave this as 4444. And again, we can set the session ID to 1. So again, I'll just make sure I do that one more time. So set session to 1, and we can hit run. All right, so it's going to start a reverse TCP handler on port 4444, and it looks like we get a Meterpreter session, a new Meterpreter session now. So I'm just going to wait for that session to load up. And by default, this particular exploit targets and executes a payload within the event viewer.exe file. So if I say get user ID, it's still going to tell me that I'm running as IE user. However, if we take a look at the processes, you can see we have administrative privileges, primarily because I can now access all the services that are running, and I can now see the user that is running them or the user that has executed them. So the only thing left that we should do now is to try and migrate to a process that has the administrator that is started by the administrative user. So again, I can try and migrate to winlogon.exe. That is also a very stable process to migrate to. So the process ID is 448. So we can try and do that. So I'm going to say migrate 448. I'm going to hit enter. It's going to migrate to that particular process, and there we are, migration successfully completed. If I say get UID, it's going to tell me I'm now NT authority and I now have administrative privileges. And again, I can prove this by saying #dump, and I hit enter, and there we are. You can see I can now dump all the relevant password hashes, which can then be used for later cracking. But now I essentially have total control over the system, and I've shown you how to perform privilege escalation manually through a persistent session. And again, we did not target any particular exploit. We've done this all we have followed all the various steps, and I've shown you how to set up how to target a particular exploit. We targeted Eternal Blue. I then showed you how to set up persistence and how to set up the listener. And then, of course, I've shown you how to elevate privileges so that we can get administrative access on the system, which we can now again use to perform. We can again execute a wide variety of commands. In the next video, we'll be taking a look at Windows 10 privilege escalation, which again is also going to be very interesting. So I'll be seeing you in the next video. Hello everyone, in this video we're going to be taking a look at Windows 10 privilege escalation. Now I already have established a Meterpreter session on the target, so again I'll just confirm and show you that we are running Windows 10, and there's a few things to take into consideration, and we're going to go through this step by step. So first of all, the architecture of the system is 64-bit, of course, and the Meterpreter session is a 32-bit session. So the first thing we want to do is we want to migrate onto a more stable process, that is of course a 64-bit process. And again, we're just going to perform some basic enumeration first of all. So if I say get user ID, you can see we are currently logged on as the Windows 10 user. And of course, if we get a shell, we can say net users, and that will display all the users on the system. And by default, we have the administrator, guest account, and Windows 10. So we want to get, again, administrative privileges. So I'll just go back into the Meterpreter session right over here, and you can see that I'm currently in the downloads folder, and I'd used the encoded payload to get access. Again, we're going to be using the exploit suggester module to suggest some exploits that we can use. But before we do that, let's try and migrate this into explorer.exe, which should be a 64-bit process. There we are, that's explorer.exe. So we're going to migrate it into process 4168, and that will give us a 64-bit Meterpreter session. So migrate, and that was, let me just go and check that one more time just to make sure that is accurate. We are looking for explorer.exe 4168. That's the process ID. So 4168, hit enter, and we'll give that a few seconds to migrate. And there we are. So sysinfo, you can see we now have a 64-bit Meterpreter session. So we're just going to background this. The version of Windows that we are running is Windows 10 build 18362. So background. And we're going to search for the suggester. So search for the suggester, and we're looking for the exploit suggester. So we'll say use, and we show the options here, show options, and we set the session. So again, if we list the sessions, so we say set session 4, right? And we're going to hit run, and that is going to start collecting the local exploits available. So again, I'm just going to wait for this to complete, and we can try out the various modules that it suggests for us. And by default, again, we're going to be targeting the bypass user account, user access control modules, because these are the ones that will give us the most success. But we'll see what other modules are currently available. So again, I'll just wait for this to complete. All right, it's currently loaded the modules, and it checked 17 exploit checks. And by default, we can see that we have a bypass user access control .NET profiler. So we can try the first exploit, which again gives us the best chance here. So I'll just copy that, and we'll say use, and we'll use that exploit. So show options, and we're going to set the session. So set session to 4. And again, the listener is set on port 4444. If I list out my sessions here, we want to change that to another port. So I'm going to say set L port. So set L port to 1234, and we're just going to hit run, right? So there we are. It looks like we're going to get another Meterpreter session here. And this looks like it was successful. So bypass UAC can bypass this setting. Continuing, this exploit requires manual cleanup of the exploit. So this is the DLL file, so we can clean that up. This is going to be very important when, especially when we talk about post exploitation, because we want to clear our traces, which is what we're going to be taking a look at in the next video. So we get a session. So if we say get UID, we're still using the Windows 10 user. What we can do is, let me just say sysinfo. This is still a 64-bit Meterpreter session. But if we try and list our processes, you can see that we have administrative privileges. So again, we need to migrate to a NT authority session service or program here that's running. And by default, we want to look for winlogon.exe. That is the most stable. So winlogon.exe, we should use that process, and it should be running as NT authority. So I'll just look for that here. It should be, there we are, winlogon, and that is NT authority, right? So we're going to say that migrate to 1820, right? So migrate to 1820, and I'll do that right now. So migrate 1820, and that's going to migrate to that particular process. And because we have administrative privileges, if I say get UID, you can see we are NT authority now, and we have administrative privileges. So I can run commands like #dump, and that'll give me all the Windows 10 hashes that we can then crack. So again, you can see it's pretty much the similar process with Windows 10. Of course, Windows 10 is much more secure in regards to the other types of post-exploitation commands that you can run, namely, taking screenshots of the desktop, starting the keylogger. That will usually cause the system to crash and restart. So that's not something you want to do. And of course, you can set up persistence just as simply as we did with Windows 7. And again, you can have a persistent presence on the system, and you can again escalate your privileges as required. That being said, that's going to be it for this video. In the next video, we'll be taking a look at how to clear our tracks using Meterpreter. Hello everyone, in this video we're going to be taking a look at how to clear event logs on Windows. Now again, when we talk about post-exploitation, an important factor in post-exploitation is clearing your tracks. And because we're dealing with Windows, and we're dealing with the Windows operating system, we have to talk about the event log and the event viewer. So if we go into our Windows VM, and we're using the Windows 10 VM now, and we search for the event viewer. The event viewer is an application that allows Windows users to view logs of their system, and essentially the logs are sorted out in terms of application security. So it essentially gives a user of a Windows system the ability to view all events that actually took place on the system, which again can indicate potential compromise, right? So this is something that you want to clear after a particular exploitation or post-exploitation where you elevated privileges. So if we take a look at the security logs right over here, you can see that we have something really curious here. So I'll just go back to the top, to the latest ones right over here. This was on the 16th. And this was an audit success, right? So this again tells us there's an audit success, which means there's a log on. And in this case, you can see it tells us there's a special log on. Now, the thing with this logon, this is not a regular logon as you would expect. And you can see that we have multiple logons. And this was us essentially authenticating with multiple Meterpreter sessions. Now, the interesting thing about this special logon is that you can see the security ID is set to system, and the account domain is NT authority, of course. But in terms of the privileges, you can see we have all the privileges that have been assigned here, which again, given that this is a special logon, should not be the case. And again, another important thing is we haven't even logged on to the the admin account on Windows. We are currently logged in as the Windows 10 user again. So I can actually just show you. I can show that to you here. If I can just list the user account that we're currently logged in as. If I go into my PC and hit properties. we're currently logged in as the Windows 10 user. So again, I'll show you that in a second. But you can see that we have all of these special logons that are all using the account domain entity authority, and essentially using the administrative user or the admin user. Again, we have a special logon. For the regular logon, you can see the account name is desktop, and it lists it out that is the Windows 10 user. So that is perfectly fine. And again, you can go through all of these event logs, and these are just security logs. If you take a look at the application logs, we have various application logs that you can look at. But all of this information can actually tell a user that their system has been compromised. So how do we clear all of this information? So what we're going to do is we'll go back into the Meterpreter session right over here, and we have an inbuilt tool with Meterpreter. And again, I'll take you to that particular tool here. A really fantastic tool that clears all of this out for us. So again, I'll just take you to that, and there we are. It's called Clear EV or Clear Event Log. And essentially what this does is it clears the entire event log, and again, a user, if they try and view the event log, there'll be literally nothing. And again, that will indicate to a certain extent that there isn't anything suspicious happening. So all we need to do is type in clear EV, and we hit enter, and there we are. You can see it's wiping 692 records from the application. It's wiping 1396 records from system, and more importantly, it's wiping 3268 records from security. So we can confirm this by going into the event viewer, and I'll just open it again. So we say event viewer, and there we go. And we'll click on Windows logs. We click on application, empty. We click on security, and we still have one here. And these are these are from 2015. So you can see we have no latest ones. These are all from not from 2015, but the 15th of September. As you can see, we are currently, if I open this up here, these are just other system events that have nothing to do with potential exploitation. And again, you can see that this was to do with the export of the persistent cryptographic key. And again, this has nothing to do with any logon of any sort. And you can see we have the log clear command that was actually executed, and that was done using the user account entity authority, which again could be a potential issue. But again, you're clearing all the other logs that might indicate potential compromise, or that might reveal information about the attacker and what they were doing on the system. So the clear EV command with Meterpreter is very, very useful at clearing your tracks on the system. And again, this concludes the post-exploitation phase of the course. I hope you learned a lot in this. So in this section, we've covered a lot of various privilege escalation techniques, and we've also taken a look at how to maintain persistence on the system. And now we've taken a look at how to clear all the event logs on Windows using the clear EV command with Meterpreter. So that's going to be it for this video, and I'll be seeing you in the next module. Hello everyone. In this module, we're going to be taking a look at password cracking and dumping hashes. So when we talk about Windows systems, as we've already mentioned in the previous module, when we're dealing with post-exploitation, a very important aspect of this is actually dumping the password hashes and then cracking them. Now, the reason you may want to do this is to get the credentials for these various user accounts on the system, which again can then be used for further attacks. So for example, if we want to start cracking the passwords for specific user accounts, we can again dump the hashes and then use a password cracking tool like John the Ripper to crack them, and then we can access those accounts either physically or remotely, because now we actually have these credentials. The second point is that these credentials may be reused on the system, and again, for example, we can use them to try out to try and see if we can log into services like databases, to log in via FTP, so on and so forth. So dumping hashes and cracking these hashes is extremely important. Now, when we talk about Windows hashes by default as for Windows versions later than Windows Server 2008 and Windows Vista, all use NTLM or the NT hash, which again is a fairly simple hash to crack, especially with tools like John the Ripper. Now, I'm currently on the Windows 7 VM, and I have a Meterpreter session, and we're going to also be doing this on the Windows 10 VM. So again, if I just say get user ID, I currently do not have any administrative privileges, and the way or the method through which I got the Meterpreter session was through the persistent session that we had set up. So again, we need to escalate our privileges, and what I'm going to do is, if I just say hash dump, which is one of the tools we'll be taking a look at right now. Hash dump is really fantastic because it actually dumps all the hashes from the SAM database. As you can see, priv password get SAM hashes. This is going to fail if you do not have administrative privileges. So in order to actually get this, what we're going to do is, I'm just going to put this in the background. So we'll say background, and we'll search for the suggester. And I'm just going to say use this particular module. So we say use, and I'm going to paste that in there, show options. And we'll leave that as it is, and we'll just say sessions, just to get the session ID. So we set the session to session 1, right? And I hit enter, and we're just going to hit run, and we'll perform our privilege escalation, after which we'll be able to run the hash dump command. Now, in the next video, we'll talk about the Windows credentials editor, which will allow us to dump the hashes without using Meterpreter. So if you have a command shell on your target as opposed to a Meterpreter session, this is a great way of dumping the hashes that way. And then again, when we'll end off this module by taking a look at cracking them with John the Ripper. So this is going to collect the local exploits. In the meantime, I'll just open up my Windows 7 VM. You can see that I have essentially created some new user accounts in addition to the other ones that currently exist. In this case, you can see we have Alexis, which I just created. We have IE user and the SSHD server account. We can create a few more new ones. So I'll just call this one, we'll just call this Mike. And this is a standard user, create account. And again, for Mike, I'll just create a password, and we'll just give it a simple password that a user might be expected to use. So we'll just say Mike password, and we'll say Mike password. And of course, this is just simply for demonstration purposes. Now, of course, I do not need to remember this password after I've set it, because we'll be cracking them. So I'll just enter a simple password hint, and I'll just say, Mike, and we'll just hit create password. So now we have a few user accounts that we can, that we can actually start cracking. But we are taking a look at firstly dumping these hashes using hash dump. So again, I'll just elevate my privileges using the bypass user account event viewer module. So we'll say use, and we'll say show options. The default payload is set to Windows Meterpreter reverse TCP. We'll set the session to 1. Set session to 1, and ensure that your active session is not in conflict with the second payload option right over here, where the L port and L host are set. So make sure your L port is not the same as the first session. So again, if I list out my sessions, you can see for my first session that I currently was running with the IE user, that is running on port 1234. So this one is fine to run on port 4444. So I'll say set session, and we'll say 1, and we'll just hit run, right? And after we've hit run, it's going to start the reverse handler, and it's going to send the stage, and we'll get a second Meterpreter session. And of course, I explained this in the previous module when we were taking a look at privilege escalation. So we'll give that a few seconds to open up. And what we can do now is we can say pgrep, and we're looking for winlogon to migrate to the winlogon process. So we'll just search for that one more time. The process ID is 404. So I'll say migrate to 404. Hit enter. It's going to migrate to that particular process. That particular process is it was started by the NT authority or the administrative account. So that will give us administrative privileges. So get user ID. And you can see we are currently as NT authority. So we can now run the hash dump command. And there we are. We were successfully able to dump the hashes from this system right over here. So this is your typical NTLM hash right over here. And the 500 denoter simply denotes that this is the administrator account. So that's something you want to keep in mind when dealing with Windows. And of course, we are going to be outputting these hashes into a file called hashes.txt. So I'll just create a new document on my Kali box here. So I'll go to my desktop and we'll just say vim. We'll say hashes windows7.txt, right? And I'll just hit enter and I'll paste these hashes in here. You can use any other text editor that you want. So now that we have the hashes there, for the Windows 7 box, we can now move on to the Windows 10 box. So what I'll do is I'll start up the Windows 10 VM and then we can get started with that there. Alright, so I've just got the Meterpreter session set up on the Windows 10 VM, and I've also escalated my privileges. So again, I'll just confirm that with you right now. So sysinfo, you can see it's running Windows 10 and we have a 64-bit Meterpreter session. And of course, if I say get use ID, we're currently logged in as NT authority. So if we say hash dump, we should be able to get the hashes, and there we are. Now, I also created a few more accounts on the Windows 10 VM just to actually test this out, and I use random passwords. So again, we have the administrator account, we have the guest account, we also have a Martin. I created an account called Martin, and we have the Windows 10 account right over here. So we'll just copy these hashes like so. So I'll just say copy selection, and what I'll do is I'll just put this into a file. So cd desktop, and we will put it in vim hashes win10.txt, right? And now we have all the hashes saved from the system. Now in the next video, we'll take a look at the Windows credentials editor so that I can show you how to dump the various password hashes if you do not have a Meterpreter session on your target. Instead, you might be having you might have a command. You might have a command line interface, or you're simply just using a command shell. So that's going to be it for this video, and I'll be seeing you in the next video. Hello everyone, in this video we're going to be taking a look at how to dump Windows password hashes from memory using the Windows credentials editor. So again, I'm currently on the website here, so ampliasecurity.com, under research and Windows credentials editor. So Windows credentials editor is a security tool to list logon sessions and add, change, list or delete associated credentials. These are NTLM hashes, plain text passwords, and Kerberos tickets. This tool can be used, for example, to perform pass the hash on Windows, obtain NTLM hashes from memory, which is what we're interested in. And the key distinction to make here in regards to the comparison between hashdump and the Windows credentials editor is that the Windows credentials editor does not dump the contents of the SAM database. Rather, it dumps the hashes, the NTLM hashes from memory from users that are currently logged onto the system, which is very important. Whereas with hashdump, you're essentially dumping the entire contents of the SAM database, which gives you the hashes for all users on the system, regardless of whether they're logged onto the system or not. However, with the Windows credentials editor, it'll only dump the hashes of users that are currently logged onto the system. And again, it also gives you the ability to obtain Kerberos tickets, but we're going to be focusing on dumping NTLM hashes from memory. Now, when we talk about the Windows credentials editor, the Windows credentials editor comes pre-packaged with Kali Linux and most of the other penetration testing distributions, and is currently available. I'll just open up a new tab here under the user share directory. So I'll just list out the contents of that directory. So user share, and we're looking under Windows resources, and we're looking for WCE, right? So if I list the contents of the WCE directory, you can see that we have the Windows credentials editor executables right over here. We have two types of executables. One of them is 32-bit, the other one is 64-bit, based on the architecture of the system you're currently working on, or the architecture of the system that you're currently targeting. So again, we need to get this particular executable onto our target system and then execute it there. Now, there's plenty of ways we can do this, and of course, we're going to assume that again you can get these executable onto the system using various forms of file transfer or various methods of file transfer, like using PowerShell or PowerShell download scripts, or in our case we'll just simply use the Meterpreter session to actually download this particular or upload this particular executable onto a directory or onto a user directory here, and then we can execute it through a shell, right? So what I'm going to do is I'll just copy the actual path to the executable, and we'll go in we'll go back into Kali here, into the Meterpreter session. And again, if I just say get use ID, you can see we have NT authority here. So I'll say CD into the root here, and I'll say CD into users, and CD into IE user. And we're currently doing this on the Windows 7 VM. So again, I'll go into the desktop, and if I list the contents of the desktop, you can see we don't have anything in here. So I'm going to upload, and to do that, we simply type in upload. I paste the path to the particular file we want to upload on the Kali VM, and the one we're looking for is wce32.exe, and that is primarily because the Windows 7 VM is 32-bit. So we'll hit enter, and that is going to upload it right over here. And if I list the contents now, you can see we have wce32.exe. Right, so to start using this, we can execute it directly from the Meterpreter. However, given that this is a command line utility, we need to get a shell session. And if you do not have a Meterpreter session, this will work fine, because again, you'll be using a command shell. So that means you're essentially interacting with the command prompt. So to execute it, all we need to do is type in wce32.exe. But before we do that, let's take a look at some of the help options that we can use. So I can say wce32.exe, and we can use the -H option to open up the help menu. Now, the options that we are looking for primarily here are going to be the first option, which will list the logon sessions and NTLM credentials. This is the default command that will be run when we run the wce32.exe, which is what we want. This is going to dump the passwords either in clear text or the NTLM credentials or hashes from memory, not the SAM database. That's very important. And then, of course, you have the ability to list logon sessions and NTLM credentials indefinitely, and this will refresh every time a new user logs in, which is also very useful if the system has a lot of users and they're currently logging into it, in various times. That being said, we are going to be looking at the second option right over here, which allows us to dump clear text passwords stored by the Digest authentication package again, and what this will do is it will dump the clear text passwords that were entered by users when they logged in. These passwords are usually stored in the memory. So we'll start off with the first option, which is the L command. So we'll say wce32.exe, and we use L, and we hit enter. And you can see it will give us the password hashes here. And of course, it's giving us the password hashes in the NTLM format or the LMNT format, where you have the LM hash, and then of course you have the NT hash right over here. Now, the LM hash was used on older versions of Windows but was discontinued. However, for compatibility reasons, you can see that Windows still preserves and combines the two, and therefore you have the NTLM hash. However, really, Windows 7 and newer operating systems only use the NT hash. And of course, we have various versions of the NTLM hash, like NTLM v1, NTLM v2, so on and so forth. Since we've already got the NTLM hashes using HashDump, our next step will involve cracking them with John the Ripper, which is again very, very simple. But we can try and dump the clear text passwords stored by the Digest authentication package. So for example, I can say wce32.exe. So I can say wce32.exe, and I use the dump option, so W. And in this case, you can see the password for the SSHD server is Darling or Darjeeling, depending on how you want to pronounce that. And the password for the IE user is password, and this is the password right over here. So immediately with the Windows credentials editor, you can see we can dump passwords in clear text, so we don't have to actually go about cracking them. That being said, we will still be cracking them with John the Ripper, because if I say net users, you can see that we have the administrator account, and that'll be extremely helpful. And of course, we have other users that are currently on the system but have not logged onto it, so we want to crack those hashes as well. So that is how to essentially use the Windows credentials editor to dump the NTLM hashes right over here, and how to dump the clear text password stored by the Digest authentication package. So that is going to be it for this video, and I'll be seeing you in the next video. Hello everyone, in this video we're going to be taking a look at password cracking with John the Ripper. More specifically, we'll be taking a look at cracking NTLM hashes. Now, in the previous videos within this module, or this section, we were able to dump all the relevant hashes from our Windows 7 virtual machine and our Windows 10 virtual machine, and we saved them into their relevant files here. So we have hashes windows7.txt and hashes windows10.txt. Now, John the Ripper is a relatively simple tool to use when it comes down to cracking various hashes. And of course, when we're talking about Windows hashes, and those are relevant to Windows 7 and later, these will typically use the NTLM hashes. Now, if I just cat the contents of one of these hashes here, or one of these files containing the hashes, an NTLM hash essentially consists of an LM hash and an NT hash, right? Now, the LM hash, as mentioned, was used in previous versions of Windows and was deprecated, and the NTLM hash is sort of kept for compatibility reasons. And again, cracking it with John the Ripper, as I said, is very, very simple. You just need to know the type of hash that you're trying to crack. That being said, when cracking passwords or hashes with John the Ripper, you need to use a word list, right? Now, word list can be created manually based on what you are able to actually predict, or whether or not you're able to predict what characters or what range of characters will be used or what range of password of characters were used in creating those particular passwords. So, for example, if you're familiar with a company's password policy and it says the password should be longer than 8 characters and they should be alphanumeric and include numbers and symbols, then you can generate word lists with those parameters in place, and you can use those word lists with for the process of cracking. Now, when we talk about the default word list that comes prepackaged with John the Ripper, that is under the user share John directory, and we can then grep that and say we're looking for passwords. And if I just grep that, this is the password.list file, which is right over here. So this is the default word list that comes with John the Ripper. Now, of course, we can utilize the ROCU word list that comes prepackaged with Kali Linux. So that is under user share word lists, and if we list that here, you can see we have the rocu.txt.gzip. So this is a compressed file, and we can actually go ahead and decompress this. So I'm going to say sudo gzip and decompress, and we're going to say user share word lists and rocu.txt.gzip and hit enter. And of course, that's going to require root privileges. So I'll just provide my password, and there we are. The file looks like it has been extracted. So if I list the contents of the word list directory again, you can see we have rocu.txt. So we're going to be using the rocu.txt word list primarily because it's extremely comprehensive. So again, using John is very, very simple, and again, it will require root privileges. So if you're currently using the root user, then you don't need to use the sudo command. So we'll start off with the Windows 7 hashes. So if I just cat the contents of the Windows 7 hashes here, so windows7.txt, you can see that we have various accounts here that we would like to actually crack in regards to the password. So the most important accounts are going to be the administrator account and of course any other user account. Now, in this particular case, since we're using a Windows 7 VM, the guest and IE user accounts do not have valid passwords. Well, actually, the IE user account does have a valid password, and of course, I added the user Mike right over here. So when cracking passwords with John the Ripper, there is not a 100% success rate, and of course it'll depend on the word list that you actually create. So you can create custom word lists, but that is going to take a lot of computational power, and again, based on the complexity of the password, it can take anywhere from a few hours to days or weeks or even months, right? So that's something that you want to take into consideration. So let's start off by cracking the Windows 7 hashes. So we will invoke the John command. So we say John, and we specify the format of the hashes. So the format are going to be of NT or NT hash, right? And then we specify the word list, which is done by specifying word list as follows. So word list, and then we specify the directory to the word list. So user share word list, and we then say rocu.txt, right? And we hit enter. But before we do that, we need to specify the file containing the hashes that we want to crack. In this case, it's going to be hashes windows7.txt, and we hit enter. And you can see the cracking process has begun, and it actually completed quite quickly. So For the guest account, you can see it actually loads all the 4 password hashes with no different salts. So again, it gives us the format. So that's NT, a standard NT hash. And then, of course, there is no open MP support for this hash type, and it uses fork. So in terms of the cracking process, you can see for the guest account, that's pretty much a blank password, which I actually told you about before. For the administrator account, as we were able to do with the Windows credentials editor, the password is password as it is. And then, of course, for the user Alexis, you can see the password is test password. So we weren't able to crack the other user password, which was the account Mike, which again we might need to crack manually, and of course that will require building our own word lists. So again, that's how simple it is to crack NTLM hashes, or NT hashes for that matter. Now let's move on to the Windows 10 hashes. So I will just use the same command, and we'll substitute the Windows 7 hash file and with the Windows 10 hash file, and hit enter. And you can see for the Windows 10 VM, we can see that we were able to crack the passwords for 2 users, one of them being the user Martin, and the other being the user Dragon123. Now, if I cat the contents of hashes windows 10.txt, this was a VM that I set up. The administrator account, I believe I did not set any particular password. I could be wrong. However, we were able to crack Martin and the other user, the other user account, which was Windows 10. So given that we're able to crack the passwords, we can then use these passwords to again open up potential or other potential access vectors like services like SSH or FTP, where we can use these user accounts and their passwords, because as I mentioned, user accounts and their relevant passwords are usually reused by users, so they don't have to remember these passwords, though they don't have to remember more than one password. So you can see that in this case, we were able to get Martin in Windows 10, and in terms of the passwords for the Windows 10 hashes, and then for the Windows 7 hashes, we were able to get the administrator password, and then of course the password for the user Alexis. So again, this information is extremely useful, because now we have direct access to the target. We know about the passwords, and we can then now tailor our attacks even more as we move along into the target network. That being said, that's going to be it for this module, and I'll be seeing you in the next module. Hello everyone. In this module, we're going to be taking a look at advanced payload encoding with various tools. One of the tools that we're going to get started with in this particular video is called Shelter. Now, you can access Shelter or the actual website at shelterproject.com. That is Shelter with 2 L's. And again, you can go ahead directly to the web page, and it'll give you a bit more information regarding this particular piece of software. So what I'll do is I'll just go back to the download page here. That is under shelterproject.com download. And you can also open up the documentation, and that'll give you more information regarding Shelter and the type of tool it is and what it does. So again, in regards to what Shelter is a dynamic shellcode injection tool, aka a dynamic PE infector. It can be used in order to inject shellcode into native Windows applications, currently 32-bit applications only. The shellcode can be something yours or something generated through a framework such as Metasploit. So what we are going to be doing is we are going to be using Shelter to inject our payloads into already existing Windows executables, for example, setup files. So again, this entire process will involve us essentially injecting or binding our Metasploit or MSF Venom payloads into a legitimate application that one would be expected to execute, or that one can use for social engineering. So for example, we can bind our payload to a common program that is usually downloaded and installed by users. An example of that is a browser or a simple utility like WinRAR. And the key thing to take into consideration here is the fact that you should be using only 32-bit standalone applications or installers by default. And of course, it should be a native Windows application. And given that the main goal is to bypass antiviruses, you should always avoid packed applications. Now, packed applications are applications that have been compressed or packed using a commercial packer, so you want to avoid them. So in this particular video, we'll be using WinRAR, as it is a standalone installer, and it's one of the simplest ways to demonstrate this. So the first thing we're going to be focusing on in this video is installing Shelter. Now, in installing Shelter is very simple. It's officially supported in the Kali repos, and you can install it by firstly updating your repositories and then clicking on apt-get install Shelter. So we're going to do that right now. So sudo apt install, and I'll say y Shelter, right? And we hit enter. Just put in my password, and that's going to begin the process. So again, I just need to specify Shelter with a double L. There we are. So you can see it's now found the package, and it's going to begin the installation process here. So we'll just wait for this to complete. And after it's completed installing, we can then get started with Shelter, and we can take a look at some basic commands. So if I click on Shelter, and you can see that will use Wine. So this particular piece of software requires Wine, because again, you're going to be generating Windows executables. So again, just let the Wine configuration begin, and again, we'll just wait for this to complete. There we are. It looks like the configuration has begun, and Shelter is going to pop up, and it's going to ask us to choose the operation mode, either auto or manual. So we'll say auto just to begin with. We now specify the PE target. The PE target is going to be your standalone executable. This is where we would specify an executable like WinRAR, and then we can we'll then, after we've specified our executable, we then go ahead and specify the various payloads that we want to use, so on and so forth. So that's going to be it for this video. I just want to take you through a bit more about what Shelter is and how to get it installed on Kali Linux. In the next video, we'll take a look at how to use Shelter to bind our payloads to legitimate applications, and then show you that you can actually execute them on a target and bypass the antivirus and get a reverse session or a Meterpreter session. So that's going to be it for this video, and I'll be seeing you in the next video. Hello everyone, in this video we're going to be taking a look at how to bind our payloads to legitimate executables, also known as injecting the payload into the executable, and we're going to be using Shelter. Now, in the previous video I showed you how to install Shelter, and using it is very simple. Just as a small word of caution, when executing Shelter, ensure you're doing this using root privileges, or you can use sudo to do that. So again, I can say sudo Shelter, and the scenario that we are going to be using for this particular example is I have downloaded I'll just open up my downloads folder on my desktop, which is where I saved it. I have downloaded WinRAR, the latest version of WinRAR. This is the 32-bit executable, and we're going to be using this as our host. So what we're going to be doing is we're going to be generating a reverse shell payload and then injecting it into the WinRAR executable, and then again, when we do that, we'll be able then to send it to the target. We're going to be using the Windows 7 VM now. And again, I'll just show you that the executable will work as normal. And of course, we'll specify stealth mode so that it actually does install the program. In addition to that, it'll also execute the payload. So this is usually great for performing social engineering attacks, where you can sort of mask executables and inject various payloads within them. So once I launch Shelter, you want to choose your operation mode, and you want to go with automatic mode for now, because Shelter does have some advanced options. So I'm going to hit A. It's going to ask us for the PE target, and that is the actual destination or the path to the executable that we want to bind the payload with. In this case, it's going to be home Kali, and it's on the desktop. And the executable name is WinRAR, and let me just confirm the name here, the WinRAR 591.exe. So I'll say WinRAR 591.exe, hit enter, and it's going to proceed, and it's going to begin the process. So first of all, it'll check if the executable is packed. As I mentioned, ensure that the executable you select as your host is not packed, and then secondly, it's going to take a look at the PE info and eliminate any information that really isn't relevant. and then of course it's going to begin tracing. So you want to give that a few seconds, up to a certain amount of minutes to actually complete tracing. So again, I'm just going to wait for this to complete tracing, as it'll take a few seconds, up to a minute, and I'll get back to you when that's done. All right, the tracing process is complete, and you can see it's going to tell us instructions traced, and it's going to start the first stage filtering. Of course, first stage filtering is complete, and we can then enable stealth mode. So stealth mode essentially allows the application, the host application, so in this case WinRAR, to be installed as a legitimate application. And of course, it's going to execute our payload for us during that process. So we'll hit yes, we want that. It's now going to ask us for the payload that we want to use. We can use a Meterpreter session or a reverse session, just using bind or reverse. Without any Meterpreter functionality. We of course want to use the first one, which is Meterpreter reverse TCP. So we'll specify the list, so L and then 1 for Meterpreter reverse TCP. We'll set our L host to my Kali IP, so 10.0.0.5, hit enter, and the L port I will set to 4444, hit enter, and it's now going to begin the compilation process. So we'll just let that compile, and it looks like it is done. So I'll hit enter, and again the executable should now be modified, and it's going to be the same executable that we had on the desktop. So it'll essentially just recompile it, and we can then use this. So what I'm going to do now is I'm just going to open up the Metasploit console, and we'll set our exploit multi-handler and set the payload to Windows Meterpreter reverse TCP. And then, of course, we will set up our web server with Python using the Python module simple HTTP server. So sudo bash, and I'll say Python simple, and we want to actually go into our desktop. So desktop, there we are. So Python simple HTTP server. And we want to open that on port 80. All right, so we use the exploit multi-handler. We can then set the payload to reverse TCP, and we show the options here. We don't need to set the L port because that is the option we set earlier. So set L host to, you can say Ethernet 0. That's my interface name, and there we are, it sets it, and we can then set up the listener. So it's going to start the reverse TCP handler, and we can now download the payload WinRAR, or the application WinRAR591.exe on our target. So I'm just going to open up the Windows 7 VM here, and we'll reload that. So this is on HTTP 10, so we'll just open it one more time again, and there we are, we have the WinRAR exe. So I'll save the file, and that should be downloaded, and there we are, we have WinRAR. It looks exactly like WinRAR. So again, we can just run it, and it's going to ask us for administrative privileges, and you can see WinRAR, the installer still works, so we can actually install that. If we go back into Kali, we go into our we go back into Metasploit, you can see we get a Meterpreter session, and again sysinfo. You can see we currently have access on the Windows 7 VM. We're not going to have administrative privileges, and that's where privilege escalation will come into play. But again, this module is just focused on showing you how to generate advanced payloads. And of course, we were actually taking a look at how to use Shelter. So you can see that it still works as the executable was designed to work. All we have done is we've injected the payload into it. That being said, that's all I'm going to be covering in this video. In the next video, we'll take a look at how to install Veil Evasion, and we'll then take a look at how to generate payloads with Veil Evasion. So I'll be seeing you in the next video. Hello everyone, in this video we're going to be taking a look at how to set up and install Veil Evasion. Now when we talk about Veil Evasion, we're talking about the latest version of Veil, which is version 3.1. The older version has been deprecated, which was version 2. So installing the latest version of Veil Evasion is extremely simple. You can install it directly if you're running Kali, because it is supported officially in the repository. So you can use it, you can install it by typing in apt y or apt install Veil. And then of course, to set it up, you want to run the script setup.sh under user share veil config. And of course, you also have the second option, which is the option where you can actually clone the repository. So git clone, and then you can run the setup like so. So again, I've already gone through the setup process, primarily because it has to download a few dependencies, and that's going to take a while. So I saved mine in my OPT folder, and if we just go into that, you can see I have the Veil directory. So this is the directory you'll be given if you go through it through the GitHub repository instead of using the Aptitude Package Manager. You can use whichever method works for you. So again, I recommend going into the config directory, and then of course you want to run the setup.sh executable script. So I'll say setup.sh, hit enter, and again you can go ahead and continue with the installation. In my case, I've already installed it, so I don't need to do it, so I'll just hit no. And or I can actually just take you through it, because it'll actually update or fix anything wrong. So it's going to update, it's going to begin installing the dependencies, and then of course it's going to update the Aptitude Package Manager. So there we are, it's going to begin installing all the necessary dependencies. One of these dependencies is going to be Wine. So you can see it's going to ask me existing Veil Wine environment detected at varlib Veil Wine. Do you want to nuke it? No, I do not, because I've my wine configuration is already set. And again, you can see once it's done, you can run Veil using the Veil.py script in the root directory, which is right over here. So if you've installed it using the Kali repositories, using the Aptitude Package Manager, you can simply just type in Veil, and that will work that way. However, if you've used the GitHub repository, you just type in Veil, and as you can see, Veil works perfectly fine here. It is recommended that you run Veil with root privileges, so I do recommend running it with sudo and then Veil, and of course the tool will work perfectly that way. That being said, that's pretty much all there is in regards to installing Veil. Of course, installing the dependencies will take a while. If you do not have Wine installed, you need to have Python Wine installed. An additional piece or additional tool that that you'll actually require is going to be PyInstaller. So to install that, you simply type in apt install, and we can search for PyInstaller. So again, I can just use the tab auto completion here. So PyInstaller, I believe it's Python 3. There we are. So it's Python 3 PyInstaller. Ensure that you have that installed, and everything should be ready to go. So again, you can check out the repository on github.com. It's under github.com Veil framework Veil, and ensure that that the version you use is version 3, because version 2 has been deprecated. That being said, that's going to be it for this video, and I'll see you in the next video when we'll get started with using Veil and generating payloads. Hello everyone, in this video we're going to be taking a look at how to generate payloads with Veil Evasion. So let's get started. By default, again, if you installed Veil using the Kali repositories, you can launch Veil using the Veil command, and ensure you launch it with root privileges using sudo, or either switch into the root user like I have. I cloned the directory, so again I'll go into my OPT directory under Veil, and I can execute it using the Veil.py script. So I can just say Veil.py, and that opens up Veil for us. All right, so we're going to be focusing on Veil Evasion and generating Python payloads. So what I'm going to do is, the syntax is very simple. As you can see, you can exit using the exit command. You can get more information using info. We can list the available tools using list. We can show the Veil configuration using options. It's very similar to the Metasploit console. We can also update Veil or use a specific tool. In our case, we want to use the available tool. In this case, we want to use Evasion. So we say use and option 1. All right, so that is going to specify Veil Evasion. And it's going to tell us we have 41 payloads loaded. So let us take a look at the payloads we have by typing in list. All right, so this will list all the various payloads that we can use, and you can see there's tons of payloads that we can use, and these are all based on various scripting languages. And of course, programming languages. We have the ability to use a C reverse interpreter session, of course, using HTTP or reverse TCP. We can use C#, we can use the Go programming language, we can use the Lua scripting language, Perl, PowerShell as well. So PowerShell will actually generate a BAT or a batch file instead of an exe. We're going to be using Python because, again, Python is quite useful. So again, we do not need to have Python installed on the target. In this case, the target is going to be the Windows 7 VM. And of course, we have the Windows Defender enabled, so we'll actually see if it'll be detected. So we'll be using Python Meterpreter Reverse TCP. So to use this, we just take a look at the number and say use option 28. So use option 28, hit enter. And these are the various options associated with this particular module. You can see they're far more advanced than your typical payload with MSF Venom. You can also specify a click track, which allows you to specify the minimum amount of clicks to execute a payload, which is awesome. Compile to exe is set to yes, because we want to compile it to an exe. As for cursor movement, we can just set that to false. We can also set a domain, an internal domain if we want. We can also set the payload to expire after a certain amount of days. That's very, very useful. We can take a look at the L host, which is we're going to set shortly, and then of course the L port, and of course we can set the minimum amount of RAM required and the minimum amount of the minimum amount of processors required. So this is like a sparse vector payload where you can set the minimum requirements for the payload to be executed. And then, of course, you can set sleep options, so on and so forth. So the only option we're going to be changing is the L host. We'll leave L port as it is. So we say set L host to the Kali IP. In my case, it's 10.0.0.5. Hit enter. And then to generate this, we say generate right over here. So generate, hit enter. And it's going to say, please enter the base name for the output file. So it's essentially asking to enter a name for your payload and the handler. So the payload name, we'll just call it, let's just call it payload, right? Just to keep things simple. Hit enter. It's now going to ask you, how would you like to create your payload executable? We want to use PyInstaller. It's always much better. So we hit option 1, hit enter. So that is going to use PyInstaller to start generating the payload for us. So what I'm going to do is we're just going to wait for that to complete. And that shouldn't take too much time at all, after which it's going to give us the various options that we need to specify. So it's very important after the payload has been generated to focus on the information that has been output. So number one, it's going to tell us the Python is language. The payload module to use is Python Meterpreter Reverse TCP. The executable has been written to this particular directory. So var lib veil output compile payload.exe. The source code has been written to var lib veil output source payload. And most importantly, we have the Metasploit resource file, which is written under var lib veil output handlers payload.rc. So it's very important when using veil evasion, if you encounter any issues setting up your exploit multi-handler, to use the Metasploit resource file that has been output, and you can see that's under handler. So we can actually set that in a few seconds. So we can just hit enter to continue, and we're essentially done with generating the payload. So what I'm going to do now is I'll just open up my other terminal here, and you can see that I'm currently in the var lib veil directory. And if I list the contents of this directory, we have the output folder. So let's go into the output. And within the output, we have the compiled directory, which will actually contain the payload.exe. Under the handler is where we have the Metasploit RC file that will set up the handler for us. Okay, so what I'm going to do now is I'm going to start the Python module simple HTTP server, so we can get the payload onto the target. So simple HTTP server, and we're going to run that on port 80. Right, and what we can do again is start up the Metasploit console, so MSF console, and we'll set up the listener using the exploit multi-handler. So again, we'll just give this a few seconds to load up. All right, so that is loaded up. So we say use exploit multi exploit multi-handler. We then we can set the options that were given to us right over here. So Python Meterpreter Reverse TCP for the module. However, it is recommended that you utilize the resource, the Metasploit resource file or configuration script that was given for the handler. So we can say resource. We then say var lib. We specify the directory to the resource under veil. So var lib veil output and we're looking for the handlers. So handlers and payload.rc, hit enter. It's now going to set up the listener for you, and it's going to say started the reverse TCP handler on the IP and the port that we specified when generating the payload. This is very important. All right, so the exploit is also running as a background job, which again is extremely useful. So what we can do now is we can actually go to our Windows 7 VM and download the payload. So we'll just open up Firefox here, and we'll go into the IP 10.0.0.5, and we have payload.exe here. So we'll click on that and we save that file, right? And we'll wait for that to be downloaded. There we are. You can see we have payload.exe, and yet it has the Python logo or icon there, the Python Windows icon. So we can just run this and hit run, and we can go back into Kali, and we go into the Metasploit console, and it's going to say Meterpreter session 1 opened, right? And you can see the connection and the IP details. And if we hit enter, you can see it appears as if our session has died. But if we click on sessions, because this is running in the background, we now have a Meterpreter session here, so we can actually go into that session. So we hit session 1 and we say sysinfo, and we have access to the Windows 7 VM, and the antivirus wasn't able to detect it. So we can also, say get user ID, and that tells us we're currently as the IE user, so we'll have to elevate privileges. But again, that's how to use Veil Evasion to generate payloads, different types of payloads, and you can change a whole ton of options regarding the payloads. So there's a lot of advanced options you can specify. As I mentioned, you can also use any of the other payloads here. It's all about just testing what works for you. So that's pretty much all that I wanted to cover in this section and in this video. So with that being said, we'll now move on to our final module or section of this course. We will be going through we'll be taking a look at exploiting the Metasploitable 3 virtual machine, which runs Windows Server 2008. So I'll be seeing you in that video.